An e-commerce platform failed to secure its application properly, leading to a significant security incident. By exploiting the vulnerability, hackers successfully breached the application and gained access to a vast amount of customer data, including usernames, email addresses, and purchase history. Does this story sound familiar to you? As an Azure security engineer, how will you secure your applications to avoid such incidents? Hello, and welcome to Secure Your Applications, the fourth course in the Microsoft Azure Security Engineer Associate Professional Certificate Training Program. My name is Ramanujam Srinivasan, and I have been a technologist for the last 25 years. I'm a certified cloud and security architect and help Fortune 500 companies formulate strategies and implement security solutions. I will be guiding you through this course. In this course, you will learn about securing applications using Microsoft solutions such as Azure Key Vault, Microsoft Identity Platform, and Azure Active Directory, frequently referred to as Azure AD. We have organized the course content into 4 weeks. In the first week, you will learn about Azure Key Vault. In the second week, you will learn how to use the Microsoft Identity Platform to provide application security. In the third week, you will learn how to achieve application security with Azure AD and other Microsoft tools. In the last week, you will do a project based on a real-life scenario and take a course-level graded assessment. Let us dive deeper and see what you will learn in these weeks. In the first week, you will learn about Azure Key Vault, a centralized cloud service for storing application secrets such as encryption keys, certificates, and server-side tokens. You will learn about the purpose of Azure Key Vault and the guidelines for using Azure Key Vault. You will also learn about configuring Key Vault access and certificates. What else is in store for you in week 1? You will learn about deploying and managing Key Vault certificates, secrets, and keys to secure application access. In addition, you will learn about Azure's hardware security module, an Azure service that provides cryptographic key storage in Azure. This week, you will practice creating a Key Vault using Azure Key Vault, and then storing a secret and a key in the Key Vault. As you progress into week 2, you will learn about the Microsoft Identity Platform. The Identity Platform helps you build applications your users and customers can sign in to using their Microsoft identities or social accounts. You will review the Microsoft Identity Platform and learn how to configure and monitor secure access to an application with the Microsoft Identity Platform. You will learn to create, configure, and use Azure AD with single-page applications. This week, you will learn about the key considerations for web apps that sign in users and call APIs. You will learn to configure authentication in daemon and non-interactive apps. During this week, you will practice creating and configuring single-page applications. You will also create server-side web apps that sign in users and call APIs. In addition, you will get the opportunity to configure authentication settings for daemon and non-interactive apps. Let's now look at week 3. This week, you will explore Azure AD authentication scenarios for different applications and the different types of permissions supported by the Microsoft Identity Platform. You will learn to register an application with app registration, create an Azure AD tenant, and configure an app registration. There's more coming your way. You will explore Microsoft Graph services and learn how to configure Microsoft Graph permissions. You will gain an understanding of managed identities and how to configure and enable managed identities. You will also learn about web app certifications and how to configure and deploy web app certificates. Experience the thrill of hands-on practice this week also. You will practice creating an Azure AD tenant and registering an application. You will also configure Microsoft Graph permissions. In addition, you will configure and enable managed identities. That's not all. You will also configure and deploy web app certificates. The fourth week, the last week of this course, will be the most interesting. We will provide you with a real-life case study. You will play the role of an Azure security engineer and make several decisions related to securing applications. This project will test your ability to apply most of the knowledge and skills you gained in this course. To refresh your knowledge, you will first get a recap of the concepts covered in the course. Following the case study-based hands-on project, you will take a course-level graded assessment, which will mimic the format of the AZ-500 exam. Eager to dive into these topics? Continue taking the rest of the readings and videos in this course and accelerate your journey toward becoming a Microsoft Azure Security Engineer Associate. You know how new technology and artificial intelligence are transforming the world? The majority of businesses use cloud services to create web applications. However, protecting sensitive data, including passwords, keys, certificates, codes, and others, poses a significant difficulty. You must have cryptographic keys to encrypt this sensitive information to meet this obstacle, which becomes more difficult as the organization expands. What if a service offered a solution to this problem and include additional features? A service called Azure Key Vault assists with managing and storing cryptographic keys. Let's begin. Hello, and welcome to the video, What is Azure Key Vault? In this video, you will learn about the Azure Key Vault, its benefits, and its best practices. You know, securing keys is essential to protect your identity and data in the cloud. Here, Azure Key Vault puts its steps and helps to safeguard cryptographic keys and secrets that cloud applications and services use. It also streamlines the key management process and lets you control keys that access and encrypt your data. The software developers create and migrate keys for development and testing to production keys within a minute. And the security administrator can grant and remove key permissions from the user whenever required. Let's understand the importance of defense-in-depth approach in Azure Key Vault. With network security, you can reduce the exposure of your vaults by specifying the IP address. Another approach is transport layer security, TLS, and hypertext transfer protocol secure, HTTPS, and where HTTPS protocol allows the client to participate in TLS negotiation. The Key Vault authentication option provides 3 ways to access Azure Key Vault that are user only, application only, and application plus user. And conditional access policies helps to apply the right access controls to Key Vault when needed to keep your organization secure and stay out of your users' way when not needed. Let's get into more detail about the Azure Key Vault. Azure Key Vault creates multiple secure containers that are known as vaults. By centralizing the storing of application secrets, these vaults assist in lowering the risk of accidental security information loss. Also, key vaults can monitor and record access to everything kept inside of them. Furthermore, TLS certificates are managed by Azure Key Vault. It offers capabilities for a reliable certificate lifecycle management solution. What challenges is Azure Key Vault able to help with? There are 4 main challenges that Azure Key Vault helps to address. The first is secrets management. In Azure Key Vault, you can safely store tokens, passwords, certificates, API keys, and other secrets where access is strictly regulated. The second is key management. Using Azure Key Vault as a key management tool, you may more efficiently generate and maintain the encryption keys used to encrypt your data. The third is certificate management. With the help of Azure Key Vault, you can quickly provision, manage, and deploy public and private TLS or secure socket layer, also called SSL certificates, for usage with Azure and your internally connected resources. And the fourth is to store secrets in hardware security models, also called HSMs, software, and Federal Information Processing Standards, also called FIPS, are 2 ways to protect secrets and keys. It is important to note that the Azure Key Vault supports application keys and secrets, but it is not intended to store user passwords. What are the most effective ways to use Azure Key Vault? The first is to grant access to users, groups, and applications at a specific scope. The pre-configured roles from Azure Role-Based Access Control, also called Azure RBAC, are available. For example, you might give the user the predefined role of Azure Key Vault contributor at a specific scope if you want to provide them with access to administer key vaults. In this instance, the scopes are subscription. The Azure role assigned at the subscription level applies to all resource groups and resources within the subscription. Resource group. The Azure role assigned at the resource group level applies to all resources in that resource group. Specific resource. The Azure role assigned for a specific resource applies to that resource. Next is to store certificates in your Azure Key Vault. The Azure Resource Manager can safely distribute certificates to Azure virtual machines, also called VMs, when the VMs are deployed. By establishing the proper Azure Key Vault access policies, you may restrict access to your certificates. Managing your certifications in one location is another advantage of Azure Key Vault. And the last is to ensure you can retrieve deleted Azure Key Vaults or Azure Key Vault objects. There are two types of deletions, intentional and accidental. You can enable Azure Key Vault's soft delete and purge protection capabilities for keys you have used to encrypt data at rest. You know that removing these keys will result in data loss. However, you can recover the vault items and delete Azure Key Vaults if necessary. Let us now talk about the service tiers in Azure Key Vault. The Azure Key Vault has two tiers. One is standard and the other is premium. The only difference is that premium tier supports HSM protected keys. How does Azure Key Vault support conditional access? Azure Key Vault supports Azure AD conditional access policies. This helps you apply the right access controls to Azure Key Vault to secure your organization. I hope you have a good understanding of the video now. Let's summarize. In this video, you have learned about definition of Azure Key Vault, its benefits, how Azure Key Vault helps to solve issues, and the best practices for using Azure Key Vault.
Imagine you work as a cloud engineer for a software development company that utilizes Azure services for its projects. The company's development team needs access to Azure Key Vault to store and retrieve sensitive information securely. Hello, and welcome to the video, Configure Azure Key Vault Access. In this video, you will learn how to access Azure Key Vault, authenticate Azure Key Vault, control Azure Key Vault access, and the benefits of Azure Key Vault. Do you know how to control Azure Key Vault access? You can control Azure Key Vault access via two interfaces, the management plane and the data plane. Let's first understand the management plane. In the management plane, you can manage Azure Key Vault by itself. It includes creating and deleting Azure Key Vaults, retrieving its properties, and updating access policies. While in the data plane, you must work with the stored data in an Azure Key Vault. Add, delete, and modify keys, secrets, and certificates here. All users or applications must have appropriate authentication and authorization to access Azure Key Vault. Authentication helps to establish an identity, while authorization determines the execution of the caller's actions. Both planes use Azure Active Directory, also called Azure AD, for authentication. The management plane uses Azure Role-Based Access Control, also called Azure RBAC, for authorization, and the data plane can use either a newly added Azure RBAC or Azure Key Vault access policy. What are the benefits of controlling Azure Key Vault access? The first is that organizations can centrally control access to all key vaults in their organization. The second is if users leave the organization, they instantly lose access to all key vaults. And the third is organizations can customize authentication using the Azure AD options, such as enabling multi-factor authentication for added security. Next, you will learn about the authentication of Azure Key Vault via Azure AD. The Azure Key Vault automatically gets associated with the Azure AD tenant once you create a Key Vault in the Azure subscription. Both the users and applications in the management and data plane must register in the Azure AD tenant and authenticate access to the Azure Key Vault. There are two ways to access Azure Key Vault applications and users. First is User plus Application Access. In this, applications access Azure Key Vault on behalf of the signed-in user, for example, Azure PowerShell and Azure Portal, while users can either access Azure Key Vault from any application or use a specific application. The second is application-only access. Here, the applications run as a daemon service or a background process, and the application identity grants access to the Azure Key Vault. It is important to note that the application authenticates with Azure AD in both types of access. Based on the application type, it uses an authentication method. Next, to grant access, it issues a token for a resource in a plane. Then the application uses the issued token and sends the REST API request to the Azure Key Vault. Now you have a good understanding of this video. Let's summarize. In this video, you have learned about how to access Azure Key Vault, how to authenticate Azure Key Vault, interfaces to control Azure Key Vault, and benefits of controlling Azure Key Vault. Imagine that your company faced a security breach. A developer accidentally pushed sensitive API keys to a public code repository. Unauthorized individuals used these keys to gain access to your systems. Could you have prevented the situation with Azure Key Vault? Hello, and welcome to the video, Review a Key Vault Example. This video illustrates the use of Azure Key Vault through an example. A company is developing an application that uses a certificate for secure sockets layer, also called SSL. The application uses Azure Storage to store data and a 2048-bit RSA key for sign operations. The application runs in an Azure virtual machine or a virtual machine scale set. How will you use Key Vault to store the application's secrets? First, identify the secrets and keys to be stored and accessed. These are the SSL certificate, the storage key for accessing the storage account, and the 2048-bit RSA key. You will also store the Bootstrap certificate, which is used to authenticate with Azure Active Directory. The next step is defining the roles to specify who can manage, deploy, and audit the application. These roles include the security team, developers and operators, and auditors. The security team consists of IT staff from the Office of the Chief Security Officer or similar contributors. The security team is responsible for the proper safekeeping of secrets. Developers and operators include the staff who develop and deploy the application in Azure and are not part of the security staff. You should not give them access to sensitive data such as SSL certificates and RSA keys. Only the application that they deploy should have access to sensitive data. The auditor role is for contributors who are not members of the development or general IT staff. They review the use and maintenance of certificates, keys, and secrets to ensure compliance with security standards. There is another role outside the application scope, called the subscription administrator or the resource group administrator. This role sets up initial access permissions for the security team. They grant access using a resource group with the resources the application requires. What tasks are performed by the security team, developers and operators, and auditors? The security team creates key vaults and turns on key vault logging. They add keys and secrets and create backups of keys for disaster recovery. The security team also sets key vault access policies to grant permissions to users and applications for specific operations. In addition, they roll the keys and secrets periodically. Developers and operators get references from the security team for the Bootstrap and SSL certificates, storage key, and RSA key for signing. These references include thumbprints for certificates, a secret uniform resource identifier, also called URI, for the storage key, and a key URI for the RSA key. Also, they develop and deploy the application to access keys and secrets programmatically. Auditors review the Key Vault logs to confirm the proper use of keys and secrets and compliance with data security standards. Two interfaces control the Key Vault access, the management and data planes. Let's look at the management plane permissions. The security team has the Key Vault contributor permission for the management plane. Developers and operators have Key Vault default permission. This permission allows deployed virtual machines to fetch secrets from a Key Vault. Auditors and the application do not have any permissions for the management plane. What about data plane permissions? The security team can create, delete, get, import, list, restore, and backup keys. They can do all operations concerning secrets. Developers and operators do not have any data plane permissions. Auditors have list permissions for keys and secrets. This permission enables auditors to inspect attributes, such as tags, activation dates, and the expiration dates for keys and secrets not emitted in the logs. The application has sign permission for keys and get permission for secrets. Along with the Key Vault permissions, the roles need access to other resources. For example, to deploy virtual machines or the web apps feature of Azure App Service, developers and operators need contributor access to those resource types. Auditors need read access to the storage account where the Key Vault logs are stored. In this video, you learned how Azure Key Vault is used through an example. You learned that you should identify the secrets and keys first, define the roles, and identify the tasks that can be performed by these roles for controlling access to application keys and secrets. In today's digital landscape, data security is of paramount importance. With the increasing prevalence of cyber threats and the need to protect sensitive information, organizations seek robust solutions to safeguard their data. One such solution is Microsoft Azure's Key Vault that enables you to store and manage cryptographic keys, secrets, and certificates. Key management in Azure Key Vault is crucial to establishing a secure foundation for your applications and services. Hello, and welcome to the video, Key Management in Azure Key Vault. In this video, you will learn about the process of creating Key Vault keys, exploring the various key types available, and the best practices for key management. Regarding cryptographic keys in Key Vault, they are represented as JSON web keys, frequently known as JWK objects. There are two types of keys, depending on how they are created, soft and hard. Soft keys are processed in software by Key Vault. These keys are encrypted at rest using a system key in a hardware security module, frequently known as HSM. As a client, you have the option to either import an existing RSA or an elliptic curve key, which is commonly known as EC key, or you can request Key Vault to generate a new one for you. On the other hand, hard keys undergo processing in a dedicated hardware security module, frequently known as HSM. These keys are protected within one of the Key Vault HSM security worlds, with each geography having its own security world to maintain isolation. As a client, you can import an RSA or EC key in soft form, which means you can bring your own key from a compatible HSM device. Alternatively, you can request Key Vault to generate a new key within the secure HSM environment. Key Vault supports multiple operations that enable secure management of keys. Let's take a closer look at some of the key functions. The first key function is Create. This operation allows a client to create a key in Key Vault. When creating a key, the key's actual value is generated by Key Vault itself and stored securely. The client does not have access to the key's value. It is worth noting that Key Vault supports the creation of both symmetric and asymmetric keys. The second key function is Import. This operation enables a client to import an existing key into Key Vault. Key Vault supports the import of both symmetric and asymmetric keys. The next key function is Update. With the update operation, a client with sufficient permissions can modify the metadata associated with the key previously stored in Key Vault. Metadata includes attributes such as the key's name, version, and other properties. This operation allows for modifying key-regulated information while retaining the underlying key value. The next key function is Delete. This operation enables a client with sufficient permissions to remove a key from Key Vault. When a key is no longer needed or is necessary to revoke access to a key, the delete operation can be used to remove the key from Key Vault securely. Once you have created a key in Key Vault, you can perform various cryptographic operations using that key. Let's take a closer look at the available operations. The first operation is Sign and Verify. Key Vault does not support hashing of content as part of signature creation. Therefore, applications should locally hash the data that they want to sign and then request Key Vault to sign the hash. This operation is called Sign Hash or Verify Hash. However, Key Vault does not support the verification of signed hashes as a convenient operation for applications that may not have access to the public key material. The next available operation is Key Encryption or Wrapping. You can use a key stored in Key Vault to protect another key, typically a symmetric content encryption key, frequently known as CEK. If the key in Key Vault is asymmetric, key encryption is used. On the other hand, if the key in Key Vault is symmetric, key wrapping is used. A key stored in Key Vault can be used to encrypt or decrypt a single data block. The size of the block depends on the key type and the selected encryption algorithm. The encrypt operation is provided as a convenience for applications that may not have access to public key material. Azure Key Vault allows you to import or generate keys within HSMs that remain within the HSM boundary to enhance security and provide additional assurance. This capability is called Bring Your Own Key, frequently referred to as BYOK. The HSMs used in Azure Key Vault are Federal Information Processing Standard publication, frequently known as FIPS 140-2 Level 2 validated, ensuring high security. It's important to note that the Thales InShield family of HSMs is utilized by Azure Key Vault to safeguard your keys. However, please know that this specific feature is unavailable in Azure China. When generating a key for the Azure Key Vault, you must adopt multiple measures to enhance security. The key generation process occurs on an offline workstation, minimizing potential attack points. This helps reduce the risk of unauthorized access to the key. Once generated, your key is encrypted using a key exchange key, frequently known as a KEK. This encryption remains until the key is transferred to the Azure Key Vault HSMs. It's important to note that only the encrypted version of your key leaves the original workstation, ensuring the confidentiality of your key during transit. Our toolset sets specific properties on your tenant key to bind your key to the Azure Key Vault security environment. This binding ensures that only the Azure Key Vault HSMs can utilize your key after receiving and decrypting it. Importantly, your key cannot be exported, and the Thales HSMs enforce this restriction. The KEK is responsible for encrypting your key generated internally within the Azure Key Vault HSMs. It is designed to be non-exportable, meaning there is no clear version of the KEK outside the HSMs. Additionally, our toolset includes attestation from Thales, verifying that the KEK was generated within a genuine Thales-manufactured HSM and cannot be exported. Moreover, Thales attests to the authenticity of the Azure Key Vault security environment. This ensures that the security world in which your key operates is also generated within a genuine Thales-manufactured HSM. Microsoft employs separate KEKs and security worlds in each geographical region for added security. This separation ensures that a key generated by a European customer, for example, can only be used within data centers located in the same region, such as Europe. Keys cannot be used across regions like North America or Asia. Let's summarize. In this video, you explored Microsoft Azure's Key Vault, a secure cloud service that allows organizations to store and manage cryptographic keys, secrets, and certificates. It provides robust solutions for data security in today's digital landscape. Key Vault supports two types of keys, soft keys and hard keys. Both types of keys offer secure key management options. Key Vault offers multiple key operations, including create, import, update, and delete. These operations enable clients to create new keys, import existing keys, modify key metadata, and securely remove keys as needed. Additionally, Key Vault supports cryptographic functions such as signing, verification, key encryption, and decryption. Imagine you're a software developer working on an e-commerce application that handles sensitive customer data. Using cryptographic keys, you have implemented encryption and decryption to protect sensitive customer data. However, you realize that storing these keys in your application code is not secure. Anyone with access to your source code or server could easily access them. Also, regularly rotating your keys can become time-consuming and error-prone. Is there any alternative? Yes, there is! Hello and welcome to the video, Manage Key Vault Secrets. In this video, you'll learn to create a Key Vault secret. You'll also learn about Azure Storage Account Key Management. As you know, Azure Key Vault provides a secure storage area for managing all your app secrets, enabling you to encrypt your data in transit or while it's being stored. So how does Key Vault store and manage secrets? From a developer's perspective, Key Vault APIs accept and return secret values as strings. However, internally, Key Vault stores and manages secrets as sequences of octets, which are 8-bit bytes with a maximum size of 25 kilobytes each. The Key Vault service doesn't provide semantics for secrets. It merely accepts the data, encrypts it, stores it, and returns a secret identifier ID. This identifier is then used to retrieve the secret later. For highly sensitive data, you should consider applying additional layers of protection. An example could be encrypting data using a separate protection key prior to storage in the Key Vault. How can you create a Key Vault secret? First, log into the Microsoft Azure portal. Then, navigate to Key Vaults. On the Key Vaults page, select the desired Key Vault. Next, under the Objects blade, select Secrets. On the Secrets page, select Generate/Import. Then, on the Create a Secret page, choose the desired upload option from the Upload Options drop-down list. In the name box, enter a unique secret name. Secret names can contain alphanumeric characters and dashes up to 127 characters. Note that your value may be copied globally for running the service. Ensure that your secret name does not include personally identifiable or sensitive information. Next, in the secret value box, enter the desired secret values. The Azure portal currently only supports single-line secret values. You'll have to use Azure PowerShell to set multi-line values. Note that the name and secret value are mandatory fields. You can optionally enter the active credential ID and content type. Key Vault allows you to specify the type of data that the secret contains in the content type box. You can indicate whether the data is a password, a certificate, or a connection string in the box. Set the activation date and expiration date if required, and then select Create. Next, let's understand how secrets are encrypted and decrypted. All the secrets in your Key Vault are stored encrypted. A unique encryption key for each vault enables the Azure Key Vault service to encrypt your secrets when you add them and decrypt them when you read them. This encryption is transparent and requires no action from the user. Key Vault can manage Azure Storage Account keys, providing a centralized and secure way to store and manage sensitive data. So, how does Key Vault manage Azure Storage Account keys? Let's look at some key points. Internally, Key Vault lists or synchronizes keys with an Azure Storage account. You can synchronize keys manually or automatically, depending on your configuration. Key Vault regenerates or rotates keys periodically to ensure security. It can automatically rotate the keys on a schedule, or you can manually trigger a key rotation. Actual key values are never returned in response to the caller. This feature helps prevent unauthorized access to the key. Key Vault manages keys for both storage and classic storage accounts to secure your accounts. Now let's recap. In this video, you learned to create a secret. You also learned how Key Vaults store and manage secrets and how they can be used to manage Azure Storage Account keys. Suppose you're a security engineer at a large enterprise. You have an Azure Key Vault application to store and manage secrets. You must consider a suitable secret rotation strategy as part of your organization's security practices. Hello, and welcome to the video, Configure Secret Rotation. In this video, you'll learn how to rotate secret values. You'll also learn how Event Grid and Function apps automate rotation. When you have secrets stored in the Key Vault, deciding on a secure rotation strategy is essential. There are several ways to rotate secret values. You can do so manually, programmatically using API calls, or automatically using an Azure automation script, which is a collection of PowerShell commands and workflows that perform specific tasks or automate processes within your Azure resources. Event Grid and Function apps are Azure services that can be used together to automate the rotation process and trigger actions based on events. Let's look at how Event Grid and Function apps automate the rotation process. In the first step, 30 days before the expiration date of a secret, Key Vault publishes a near expiry event to the event grid. Then, the event grid checks event subscriptions and uses the Hypertext Transfer Protocol HTTP POST method to call the function app endpoint subscribed to the event. Next, the function app receives the secret information, generates a new random password, and creates a new version of the secret with a new password in Key Vault. Finally, the function app updates the structured query language SQL server with the new password. Let's summarize. In this video, you learned that you can rotate secret values manually, programmatically using API calls, or automatically using an Azure automation script. You also learned how Event Grid and function apps automate the rotation process. Your organization uses Azure Key Vault to store sensitive cryptographic keys, certificates, and secrets. You would want to safeguard your Key Vault objects from disasters, data corruptions, and other unforeseen circumstances, right? Hello, and welcome to the video, Manage Key Vault Safety and Recovery Features. In this video, you'll learn to safeguard your Key Vault keys, certificates, and secrets using two features, Key Vault Soft Delete and Key Vault Backup. Let's look at these features in detail. Key Vault Soft Delete feature allows the recovery of deleted Key Vaults and Key Vault objects, like keys, secrets, and certificates. To appreciate the importance of soft delete protection, let's understand the process flow when you delete a secret with and without soft delete protection. When you delete a secret and the Key Vault does not have soft delete protection, it is permanently and irrevocably deleted. However, when you delete a secret and the Key Vault has soft delete protection, you must perform two operations to delete it permanently. First, delete the secret that puts the Key Vault into the soft delete state. Second, purge the secret in the soft deleted state. This operation requires additional access policy permissions, which reduces the risk of a user accidentally or maliciously deleting a secret. In the soft delete state, an object will remain recoverable for a configurable period of 7 to 90 days. The default recovery period will be 90 days if no configuration is specified. By default, Microsoft now enables soft delete protection on all Key Vaults, and users will no longer be able to disable soft delete. Next, let's look at the second feature, Key Vault Backup. You can back up secrets, keys, and certificates in your Key Vault. The backup will provide an offline copy of all your objects if you lose access to your Key Vault. You can also download a backup of your secrets, keys, and certificates on the Azure portal. However, note that there is currently no way you can back up your entire Key Vault instance. In this video, you learned how to safeguard your Key Vault keys, certificates, and secrets using the Key Vault Soft Delete and Key Vault Backup features. Congratulations! You have completed learning about the guidelines for using Azure Key Vault, configuring Key Vault access, and managing access to secrets, certificates, and keys. Let's recap what you learned. To start with, you were introduced to the Azure Key Vault, a centralized cloud service for storing application secrets, such as encryption keys, certificates, and server-side tokens. You learned about the 4 capabilities of Azure Key Vaults: secrets management, key management, certificate management, and secret storage backed by hardware security modules, or HSMs. You went on to learn that there are 3 primary concepts used in a Key Vault: vaults, keys, and secrets. Vaults help reduce the chances of accidental loss of security information by centralizing application secret storage. Keys, the central actor in the Key Vault, are cryptographic assets destined for a particular use. There are 2 variations of keys in the Key Vault: hardware protected and software protected. The secrets are small data blobs protected by an HSM-generated key created with an Azure Key Vault. You were also introduced to the best security practices for using Key Vault. Next, you learned that you can control Key Vault access via two interfaces, the management plane and the data plane. Both planes use Azure Active Directory, also called Azure AD, for authentication. The management plane uses Azure Role-Based Access Control, also called Azure RBAC, for authorization, and the data plane uses either a newly added Azure RBAC or the Key Vault access policy. You are also acquainted with the two ways to access Azure Key Vault applications and users. The first way is User Plus Application Access, where applications access Azure Key Vaults on behalf of the signed-in user. The second way is Application-Only Access, where applications run as a daemon service or a background process. Then, you learned how Key Vault is used through an example. You learned that you should first identify the secrets and keys, then define the roles, and finally, identify the tasks that can be performed by these roles for controlling access to application keys and secrets. You learned to deploy and manage Key Vault certificates. You understood that a certificate policy contains information on how to create and manage the Azure Key Vault certificate lifecycle. You also explored adding certificates to an Azure Key Vault and then retrieving them. You not only learned theoretical concepts, but also reinforced your learning by actively engaging in a hands-on exercise to create a Key Vault. Next, you learned that key management in Azure Key Vault is crucial to establishing a secure foundation for your applications and services. You learned that cryptographic keys in a Key Vault were represented as JSON web keys, frequently referred to as JWK objects, and that there are two types of keys, soft keys and hard keys. You were then taken through an example of storage service encryption with customer-managed keys. Next, you learn that Key Vaults store and manage secrets as sequences of octets, which are 8-bit bytes with a maximum size of 25 kilobytes each. You also understood how Key Vaults manage Azure Storage Account keys. So, is there a secure secret rotation strategy? Yes, there is. You learned that you could rotate secret values manually, programmatically using API calls, or automatically using an Azure automation script. You also learned about Event Grid and Function Apps, which are Azure services that can be used together to automate the rotation process and trigger actions based on events. Next, you learned that Azure Key Vault Access involves managing the Key Vault itself and accessing its data. Authentication is done through Azure AD, while RBAC is used for authorization. You also learned that access policies define permissions for reading and writing data. You then went on to learn how to safeguard your Key Vault keys, certificates, and secrets using two features, Key Vault Soft Delete and Key Vault Backup. Key Vault's Soft Delete feature allows the recovery of deleted Key Vaults and Key Vault objects. Key Vault's Backup feature allows you to back up secrets, keys, and certificates, and provides an offline copy of all your objects if you lose access to your Key Vault. Next, you learned that once you have a Key Vault, adding and managing secrets can be done from any Azure administrative interface, including the Azure portal, the Azure command line interface, frequently referred to as Azure CLI, and Azure PowerShell. Once again, you had the opportunity of a hands-on exercise where you practice storing a secret and a key in a Key Vault. What an incredible learning experience that was! You are now ready to move to the next step of attempting the graded assessment for this module. Good luck with the module quiz!
As a security engineer, you need to ensure the security of the company's website and application. You must implement a comprehensive application security program to protect the company's assets, data, and reputation. Hello, and welcome to the video, What is Application Security? In this video, you will learn about application security in terms of defense in depth, aspects of security assurance, classification of application tasks, and the fundamental components of Azure services. Let's begin with the defense in depth concept. You know the digital world is changing with more persistent, sophisticated, and driven cybercriminals. Therefore, trust is a more critical component of risks and threats. At Microsoft Azure, the security approach focuses mainly on the defense in depth, which helps to protect information from unauthorized access. It has layers of protection built throughout all phases of design, development, and deployment of the platforms and technologies. Azure can host legacy and modern applications through infrastructure as a service called IaaS, virtual machines called VMs, and platforms as a service called PaaS. Let's discuss the 5 aspects of security assurance. First is the application code. Your written code defines the custom application. Secure code requires identifying and mitigating risk from the application's design and implementation perspective. Next is the application services. The cloud-based services that applications use include databases, identity providers, event hubs, and the Internet of Things, frequently referred to as IoT device management. The security implications and use of the service instances fall under the purview of the application owner. And last is the application hosting platform. The application hosting platform is a computing environment where the application runs. Let's look at the application hosting platform legacy application. The legacy application requires a complete operating system, also called OS, hosting on real or virtual. The infrastructure teams that manages the OS deploy middleware and own the application. The security responsibility depends on 2 aspects. On premises, the application owner is responsible for maintenance and security. IaaS, the underlying infrastructure is the responsibility of the cloud provider. VMs, OS, and other installed components are the responsibility of the application-owned organization. Next aspect of security assurance is modern applications. In modern applications such as Azure Application Service, the cloud provider and application owners secure the underlying OS, while the application owners oversee the protection and configurations of the application service. The containers are an application packaging technique where applications are isolated from the environment in which they function. These applications run on a container service by the cloud provider or a server managed on-premises or in IaaS. Do you know how to identify and classify application risks? Identifying applications with a high potential impact or exposure to risk is challenging. There are 5 specific parameters to identify and classify application risks. Business critical data tells that the applications that process or store information must have the assurance of confidentiality, integrity, and availability. Next is regulated data. You can use standards such as the payment card industry, also called PCI, General Data Protection Regulation, also called GDPR, and Health Information Portability and Accountability Act, also called HIPAA, for the applications that handle monetary instruments and sensitive personal information. Then there is critical business availability, which talks about the applications. In this, functionality is vital for the business. Next is significant access. Here, the system accessible applications have a high impact through technical means, such as stored credentials, keys, or certificates that grant access to the data or service, and permissions granted through access control lists or other methods. And the last is high exposure to attacks. The attackers target web applications on the public internet and legacy applications more quickly due to increased vulnerabilities. Let's now talk about how to use Azure services for fundamental components. Developers can use cloud provider services like databases, encryption, identity directory, and authentication instead of building or adopting custom implementations or third-party solutions. These services provide better security, reliability, and efficiency. Developers should use cloud services from the cloud provider for identity, data protection, key management, and application configurations. There are 6 services for cloud provider. The first service is identity. User directories and other authentication functions are complex to develop and critical to security assurances. You can choose Azure Active Directory, also called Azure AD, Azure AD B2B and B2C, or third-party for authentication and granting permissions to users, partners, customers, applications, and services. Next is data protection. It helps to establish capabilities from cloud providers, such as native encryption in cloud services, to encrypt and protect data. Then there is key management. It always authenticates with identity services rather than handling a cryptographic key. Also, application configurations tell that varying application configurations can create security risks. You can store application configuration information within the application in Azure App Configuration or Azure Key Vault. The next is to use native capabilities. Instead of using external security elements like data encryption, network traffic filtering, threat detection, and other features, you can employ these capabilities in cloud services. And the last is to use an application gateway with Web Application Firewall, also called WAF. It will help to protect public-facing websites from different types of attacks. I hope now you have a good understanding of the application security. Let's summarize. In this video, you have learned about application security using defense-in-depth approach, the essential aspects of security assurance if you have an owner role, identification and classification of application risks, and Azure services for fundamental components.
Imagine you're an IT manager for an organization. As a part of your responsibilities, you need to review a secure and reliable identity management solution to streamline user authentication and access to various company resources. To begin with, you've created a test environment using Microsoft Azure Active Directory, also called Azure AD. Hello, and welcome to the video, Review the Microsoft Identity Platform. In this video, you'll learn about the Microsoft Identity Platform in detail, endpoints, and the Microsoft Authentication Library, also called MSAL. Let's begin by explaining the Microsoft Identity Platform. The Microsoft Identity Platform is an extension of Azure AD Developer Platform. It enables developers to create programs that let users sign in and obtain access tokens for calling third-party APIs, such as Microsoft Graph or their custom APIs. The Microsoft Identity Platform comprises an authentication service, open-source libraries, application registration, and configuration via a developer portal and application API. It includes comprehensive developer documentation, quick start examples, code samples, tutorials, how-to guides, and other developer-specific materials. The Microsoft Identity Platform supports industry-standard protocols, including Open Authentication Tokens, also called Oath version 2.0 and OpenID Connect. Through MSAL and Azure AD Business to Consumer, also called Azure AD B2C, you can expand the user database with the aid of the Microsoft Identity Platform. You may register and set up your application using the Azure interface. You can also use Microsoft Graph API to configure applications programmatically. For example, work and school accounts, Azure AD provisioned accounts, personal accounts such as Outlook.com or Hotmail.com, customers with personal social identities such as LinkedIn, Facebook, and Google. Let's look at the diagram which shows the Microsoft Identity Platform for developers. It includes app registration experience, endpoints, and supported identities. The Microsoft Identity Platform has two endpoints, namely versions 1.0 and 2.0, but it's advised to use version 2.0 as the default endpoint when working on a new application for a while. Use version 2.0 as the default endpoint when working on a new application for a while. Most developers use the Azure AD version 1.0 platform to authenticate work and school accounts created using Azure AD. They must use the Azure portal for application registration and configuration, the Microsoft Graph API for programmatic application configuration, Azure AD Authentication Library, also called ADAL, and the Azure AD version 1.0 endpoint to request tokens. When MSAL integrates with the Microsoft Identity Platform, ADAL integrates with the version 1.0 endpoint of Azure AD for developers. In this version, you can support work accounts. The version endpoint is a unified Microsoft personal account with a single authentication scheme. Additionally, MSAL enables Azure AD B2C authentications. Let's now learn about the unified Microsoft Identity Platform. Version 2.0 of the unified Microsoft Identity Platform makes developing code and integrating any Microsoft identity into your application easier. You can use endpoints for several platforms using the open-source, fully supported MSAL against the Identity Platform. It's easy to use, offers excellent single sign-on, also called SSO experiences to users, and aids in achieving high reliability and performance. While using APIs, you can set up your program to benefit from incremental consent. This enables you to wait until the application's usage justifies it at runtime before requesting approval for more intrusive scopes. To provide your clients with SSO access to the applications and APIs, MSAL also supports Azure AD B2C. This way, they may use their preferred social business or local account credentials. Now let's look at the Microsoft Authentication Library and application scenarios. These are single-page applications, for example, JavaScript, web app sign-in users, calls a web API on behalf of the user, protecting a web API so only authenticated users can access it. Web API calls another downstream web API on behalf of the signed-in user. Desktop application calls a web API on behalf of the sign-in user. The mobile application calls a web API on behalf of the user who's signed in interactively. Desktop or service daemon application calling web API on behalf of itself. Next, we'll talk about the Microsoft Authentication library languages and their supported platforms and frameworks. I hope now you have a good understanding of this video. Let's summarize. In this video, you've learned about what is Microsoft Identity Platform, endpoints of Microsoft Identity Platform and its uses, what is a unified Microsoft Identity Platform, Microsoft Authentication Library, and its supported platforms and frameworks. As a security engineer, you must develop a high-performance web application, frequently referred to as a web app, for efficient task management and team collaboration. The app should prioritize responsiveness and a smooth user experience. Additionally, it must adhere to stringent security measures, exclusively allowing access to authorized users within the organization. Are single-page applications, frequently referred to as SPAs, a feasible option? Hello, and welcome to the video, Single-Page Applications. In this video, you'll learn about SPAs. You'll also learn to register an Azure AD application and configure an SPA using the OAuth 2.0 authorization code flow. Modern web apps have higher user expectations and greater demands than ever before. They are expected to be available 24/7 from anywhere in the world and usable from virtually any device or screen size. And so, web apps must be secure, flexible, and scalable. How do these web apps ensure rich user experiences? Modern web apps use client-side technologies like JavaScript and modern web APIs that allow dynamic and interactive interfaces. These web apps can also handle complex scenarios and provide a more intuitive user experience. With the advancement of web standards and browsers, developers can now create sophisticated client-side applications, which are what we commonly call SPAs. SPAs enable users to authenticate and obtain tokens from the Microsoft Identity Platform. These tokens can then be used to call secured web APIs. SPA is a dynamic web application that runs entirely on the client side in the browser, usually on a single web page. SPA must be served up as a routable page with a web server. So when should you choose an SPA style of development for your web app? Let's look at 3 key factors. 1. When your app is expected to have a rich user interface with interactive features. SPAs can support rich client-side functionality that doesn't require reloading the page as users take actions or navigate between areas of the app. SPAs load faster, fetching data in the background, and individual user actions are more responsive since full-page reloads are rare. 2. When your team is familiar with JavaScript or TypeScript development. Building SPAs requires proficiency in JavaScript or TypeScript. These languages are commonly used with modern SPA frameworks like Angular, Vue, or React. And 3. When your app must expose an API for other internal or public clients. SPAs extensively use web APIs to query and update data as users interact with the app. Most modern web apps are built as client-side SPAs and written using JavaScript or SPA frameworks. These apps traditionally used the OAuth 2.0 implicit flow to authenticate and obtain an access token to connect to protected resources. But does the OAuth 2.0 implicit flow pose security risks? Do modern browsers use them? The pattern used to implement implicit flow in SPAs included iframes and cookies for silent single sign-on in the browser. However, most modern browsers now block third-party cookies that break that implementation. This, along with security concerns regarding the visibility of access tokens when using the implicit grant flow, led to the decision to move to the OAuth 2.0 authorization code flow for SPAs. What's the easiest way to use the Microsoft Identity Platform for authentication and to obtain access tokens to authorize requests to secured endpoints in SPAs? Use the Microsoft Authentication Library, frequently referred to as MSAL for JavaScript. MSAL.js 1.x only supports the use of the implicit flow. However, in July 2020, Microsoft released MSAL.js 2.0, which supports using the authorization code flow. For the SPA to use Microsoft Identity to enable users to authenticate and obtain access tokens for services like Microsoft Graph, you must register a new app with Azure AD. You can do this using the Azure AD Admin Center. After you register the app, configure it to use the SPA platform. Let's first register an Azure AD application. To register an Azure AD application supporting single-tenant accounts, first sign into the Microsoft Azure portal. Then navigate to App Registrations in Azure Active Directory and select New Registration. On the Register an Application page, in the name box, enter the user-facing display name for your application. Note that this is a mandatory field but can be changed later. Next, under Supported Account Types, select who can use this app or access this API. We're creating a single-tenant app, so we'll select accounts in this organizational directory only, default directory only, single-tenant. Then select Register to create the application. On the newly created application page, copy the application client ID and the directory tenant ID. You'll need these values later. Next, from the Manage blade, select Authentication. On the Authentication page of the newly created application, select Add a Platform. Then in the Configure Platforms panel that appears, select Single Page Application. In the Configure Single Page Application panel, in the Redirect URIs box, enter the desired Uniform Resource Identifier, frequently referred to as URI. Note that this is a mandatory field. Redirect URIs will be accepted as destinations when returning authentication responses or tokens after successfully authenticating or signing out users. Note that the redirect URI you send in the request to the login server should match the one listed here. Redirect URIs are also referred to as reply URLs. Then in the front channel logout URL box, enter the desired URL. This is where we request that the app clear the user's session data. This URL is required for a single sign-out to work correctly. The Implicit Grant and Hybrid Flows section requests a token directly from the authorization endpoint. If the app has a single-page application and doesn't use the authorization code flow, or if it invokes a web API via JavaScript, select both access tokens and ID tokens. For ASP.NET, Core web apps and other web apps that use hybrid authentication, select only ID tokens. Recall that msal.js 2.0 does not support implicit grant. Enable implicit grant settings only if your app is using msal.js 1.0. Then select Configure. When the authentication page refreshes, select Add URI. Enter the desired URL and then select Save. OAuth configuration depends on the web app's runtime, such as Hypertext Preprocessor or PHP, Java, Python, .NET Core, etc. You can follow the documentation suggested by the specific application runtime. However, you'll need the following information to configure authentication: application client ID, directory tenant ID, secret value. It's time to summarize. In this video, you learned that SPAs are dynamic web apps that run entirely client-side in the browser, usually on a single web page. You also learned to register an Azure AD application and configure an SPA using the OAuth 2.0 authorization code flow. You're a developer in a multinational organization that wants to build a web application frequently referred to as a web app. The organization decides to build the app using ASP.NET Core and host it in Azure. How will you implement a web app that signs in users and calls APIs in Azure Active Directory, frequently referred to as Azure AD? Hello, and welcome to the video, Register Web Apps that Sign in Users and Call APIs. In this video, you'll learn to register a single-tenant Azure AD app and create a client secret for the app. You'll also learn to configure authentication for web apps using Azure AD. Web apps are typically used to build apps that require user authentication and authorization to access protected resources, such as APIs or data. As a developer, you can leverage the Microsoft Identity platform by adding authentication to web apps. Adding authentication allows web apps to access limited profile information and customize the user experience. Let's discuss user authentication in web apps. Web apps authenticate a user in the web browser. When a user attempts to access a web app, they are redirected to the Azure AD sign-in page for authentication. Once the user successfully signs in, Azure AD redirects them back to the web app. Azure AD then provides a sign-in response, which includes an identity token containing various claims about the user. These claims provide information like the user's identity and other relevant details. The web app then uses the identity token to request data from web APIs like Microsoft Graph. These web apps typically use the OAuth 2.0 protocol to authenticate and authorize users and obtain access tokens to call APIs. Let's discuss the OAuth 2.0 authorization code grant flow. The OAuth 2.0 authorization code grant flow is common when websites or custom apps leverage Azure AD as a federated authentication provider. When the app needs a user to sign in or an access token to act on their behalf, it redirects the user to Azure AD's authorization endpoint to authenticate. After the user successfully signs in with their email and password, Azure AD redirects them to a specific URL in the web app. When Azure AD redirects the user to the web app, it includes an authorization code. The authorization code is an encoded string that only Azure AD can read. The web app takes this authorization code, which is valid for a short period, and includes it in a request to the Azure AD token endpoint. What's the benefit of the OAuth 2.0 authorization code grant flow? Enhanced security is one of the main benefits of the OAuth 2.0 authorization code grant flow over the implicit grant flow. The web app never sees your username and password. All authentication happens on Azure AD, and the app only gets the authorization code from the sign-in process, making it very secure. So what must you do for an app to use the Microsoft Identity Platform and enable users to authenticate and obtain access tokens for use with services like Microsoft Graph? That's right, register an app with Azure AD using the Azure AD Admin Center. When registering an app in Azure AD, ensure the Redirect Uniform Resource Identifier, URI, of the app points to the callback URL of the web app. This callback URL must match the redirect URI provided by the app when the authentication process starts. The authorization code will be sent to this endpoint, which means you need to configure any authentication libraries to listen on this endpoint and receive the authorization code. A sign-out URL should also be specified so the authentication libraries delete any cached tokens or data that are only required for signed-in users. To register a single-tenant Azure AD app, first sign into the Microsoft Azure portal, then navigate to App Registrations in Azure Active Directory and select New Registration. On the Register an Application page, in the name box, enter the user-facing display name for your web app. Note that this is a mandatory field but can be changed later. Next, under Supported Account Types, select who can use this app or access this API. As we're creating a single-tenant app, so we'll select accounts in this organizational directory only, default directory only, single tenant. Then select Register to create the app. For this example, we created an app called Identity Web App. On the newly created app page, copy the application client ID and the directory tenant ID. You'll need these values later. Next, let's look at how to configure a web app. From the Manage blade, select Authentication. On the Authentication page of the newly created app, select Add a Platform. Then, in the Configure Platforms panel that appears, select Web. In the Configure Web panel, enter the desired URI in the Redirect URIs box. Then, in the Front Channel Logout URL box, enter the desired URL. Here, we request that the app clears the user's session data. This URL is required for single sign-out to work correctly. The Implicit Grant and Hybrid Flows section requests a token directly from the authorization endpoint. If the app has a single-page application and doesn't use the authorization code flow, or if it invokes a web API via JavaScript, select both access and ID tokens. Select only ID tokens for ASP.NET Core and other web apps that use hybrid authentication, then select Configure. When the authentication page refreshes, select Add URI, enter the desired URI, and then select Save. Now that you've registered an app, let's look at how to create a client secret for the app. For the web app to run without user involvement, it'll sign in to Azure AD with an application ID and a certificate or a secret. We'll use a secret for this example. Navigate to App Registrations in Azure Active Directory and select the desired web app. On the desired web app page, under the Manage blade, select Certificates and Secrets. Next, on the Certificates and Secrets page, select New Client Secret. In the Add a Client Secret panel, enter a description for the client secret. Then select the desired expiration duration from the Expires drop-down list. Note that you can also create a custom expiration duration. Then select Add. The Certificate and Secrets page will display the new secret. You must copy this value as it's only shown this one time. If you leave the page and return, it'll only be shown as a masked value. OAuth configuration depends on the web app's runtime, such as Hypertext Preprocessor or PHP, Java, Python, .NET Core, and so on. You can follow the documentation suggested by the specific application runtime. However, you'll need the following information to configure authentication: application client ID, directory tenant ID, secret value. Let's wrap up. In this video, you learned that web apps are typically used to build apps that require user authentication and authorization to access protected resources. You learned that one of the main benefits of the OAuth 2.0 authorization code grant flow is that the web app never sees your username and password, making it very secure. You also learned to register a single-tenant Azure AD app and create a client secret for the app. Most applications, frequently referred to as apps, expect user interaction to authenticate and obtain tokens to call web APIs on behalf of users. But what about apps that need to run without user interaction? Hello, and welcome to the video, Configuring Authentication in Daemon and Non-Interactive Apps. In this video, you'll learn about daemon and non-interactive apps. You'll also learn to register an app that obtains tokens without user interaction and add permissions to the app. Apps that run without user interaction are called daemon apps. Some examples of daemon apps include web apps that perform batch processes in a directory, desktop apps such as Windows services on Windows or daemon processes on Linux that perform batch jobs, and web APIs that need to manipulate directories and not specific users. Developers can create apps that obtain tokens without user interaction using the OAuth 2.0 client credentials flow. You can't deploy a daemon app to a regular user's device, and a regular user can't access a daemon app. Only a limited set of IT administrators can access devices that have daemon apps running. This restricted access ensures that a bad actor does not access a client secret or token from device traffic and act on behalf of the daemon app. Do non-daemon apps use the OAuth 2.0 client credentials flow? Yes, when an app acts on behalf of users but needs elevated privileges that a user doesn't have. It accesses a web API or resource with its own identity, not the user's identity. These apps are called non-interactive apps. Some examples of non-interactive apps or non-daemon apps include a mobile app that accesses a web service on behalf of an app but not on behalf of a user, and an Internet of Things device, frequently referred to as an IoT device, that accesses a web service on the device's behalf, not on the user's behalf. Apps that acquire a token for their own identities are confidential client apps, given that they access resources independently of a user. These apps need to prove their identity when accessing resources. They are considered sensitive apps and must be approved by Azure Active Directory, frequently referred to as Azure AD tenant administrators. To authenticate themselves, these apps register a secret, which can be an app password or a certificate with Azure AD. The secret is then securely stored and passed during authentication to get a token from Azure AD. How does the OAuth 2.0 client credentials flow work? Does the app need to sign in to obtain an authorization code? No. During the Azure AD app registration process, you create a secure sockets layer or SSL certificate public and private key pair. The public certificate is registered with your Azure AD app. Within the service or daemon app, the private certificate is used to sign a JSON web token or JWT that is sent to the token endpoint. Administrators can also use a client secret instead of a certificate, but this is not recommended for production. For a service or daemon app to use the Microsoft Identity Platform to enable users to authenticate and obtain access tokens for use with services like Microsoft Graph, you must register a new app in Azure AD. To register a new app, on the Register an Application page, enter the name for the application in the mandatory name box. Daemon applications make sense only in Azure AD tenants. So when you register the app, choose one of the following options in the Supported Account Types section. Accounts in this organization directory only, or accounts in any organizational directory. The accounts in this organizational directory only option is most commonly used as daemon applications are written by line of business, LOB developers. Choose the accounts in any organizational directory option if you're an independent software vendor, ISV, providing utility tool to your customers, as you'll need your customers' tenant admins to approve it. You don't need to register the redirect URI if your confidential client application only uses the OAuth 2.0 client credentials flow. Then select Register. A unique aspect of apps that use the client credentials grant flow is that their permissions must be defined ahead of time. These are also referred to as static permissions. To add permissions to a daemon app, under the Manage blade of the desired daemon app, select API permissions. Then select Add a permission. In the Request API Permissions panel, select Microsoft Graph. Next, select Application Permissions. A daemon app can only request application permissions to APIs, not delegated permissions. Then select the desired permissions and choose Add Permissions. Notice that the permissions have Yes listed in the column Admin Consent Required, indicating that an administrator must grant these permissions. On the API Permissions page, select Grant Admin Consent for Default Directory. To grant all users in your organization this permission, in the Grant Admin Consent Confirmation box, select Yes. Observe that permissions for the default directory have been granted. Users can't interact with the daemon app because it requires its own identity. The daemon app requests an access token by presenting its application client ID, client credentials, which include a certificate or a secret, and the application ID URI to Azure AD. As with any confidential client application, you need to add a certificate or secret to act as that application's credentials, so it can authenticate itself without user interaction. After successful authentication, the daemon receives an access token and a refresh token from the Microsoft Identity Platform. This token is then used to call the web API and is refreshed as needed. In this video, you learned about daemon apps and non-interactive apps. Daemon apps run without user interaction. Non-interactive apps take users' inputs but require their own identity to access certain services. You also learn to register an app and grant permissions. Congratulations, you've completed learning about the Microsoft Identity Platform, registering web applications, also called apps, and daemon and non-interactive applications. Let's recap what you've learned. The defense-in-depth approach was the main focus of your initial introduction to application security. It aids in safeguarding data from unauthorized access. The platforms and technologies have layers of security built into them at every design, development, and deployment stage. The 5 components of security assurance you've learned about are application code, application services, application hosting platforms, modern applications, and containers. You also discovered that the Azure Active Directory, also called Azure AD, is a developer platform and a subset of the Microsoft Identity Platform. The Microsoft Identity Platform consists of an authentication service, open source libraries, application registration, set up via a developer portal, and APIs for specific applications. Additionally, it supports standard protocols in the business such as OpenID Connect and Open Authentication Tokens, also called OAuth 2.0. Microsoft Identity Platform for developers includes app registration experience, endpoints, and supported identities. Then you progress to single-page applications, or SPAs, which are dynamic web applications that are client-side in the browser and often run on a single web page. You can choose the SPA development style for your web app for the cases when the application should have a rich user interface with interactive features. The team is familiar with JavaScript or TypeScript development. An application must expose an API for other internal or public clients. The most recent web apps are written in JavaScript or SPA frameworks and developed as client-side SPAs. In the past, these apps connected to protected sites using the implicit OAuth 2.0 route to authenticate and get an access token. The Microsoft Authentication Library, also called MSAL or JavaScript, is the most convenient way to use the Microsoft Identity Platform for authentication and to receive access tokens to authorize requests to secure endpoints in SPAs. You learned theoretical concepts and reinforced your learning by engaging in a hands-on exercise to create and configure single-page applications. You must sign into the Microsoft Azure portal and access the Azure AD. Here you should select app registrations and select New Registration, and then enter the required details to select Register. Next, from the Manage blade, select Authentication. Select Add a Platform on the newly created application's authentication page. Then, in the Configure Platforms panel that appears, select Single Page Application. Enter the required details in the Configure Single Page Application page, and then select Configure. Then you move to the Register web apps that sign in users and call APIs. You begin by creating web applications that call APIs and sign in users. You can create a web app using OAuth 2.0 protocol that needs user authentication and authorization to access restricted resources like APIs or data. Over the implicit grant flow, the preferred code grant flow is OAuth 2.0. Then you discovered how to set up an application on the Azure interface, including registration. The client's secret invention came next. It's vital to remember that OAuth configuration depends on the web app's runtime, which may be Java, Python, .NET Core, or PHP. Again, you had an opportunity to explore the practical understanding of creating server-side web apps that sign in users and call APIs via hands-on exercises through the Microsoft Azure portal. What else did you learn? You learned about configuring authentication in daemon and non-interactive apps. The applications that run without user interaction are called daemon apps. The daemon app can only request application permissions to APIs, not delegated permissions. In contrast, non-interactive applications act on users' behalf but need elevated privileges that a user doesn't have. It accesses a web API or resource with its identity, not the user's. You also learn to register a daemon app, grant permissions, and grant admin consent for Azure AD. During the Azure AD app registration, you can create a Secure Sockets Layer, or SSL, a certificate for public and private key pairs. The service or daemon app uses the private certificate to sign a JSON web token, also called JWT, provided to the token endpoint. Administrators can also use a client secret rather than a certificate. Lastly, you had an opportunity to apply your theoretical learning of daemon and non-interactive apps to the hands-on exercise about configure authentication in daemon and non-interactive apps. What an incredible learning experience that was. You're now ready to move to the next step of attempting the graded assessment for this module. Good luck with the module quiz.
As a software developer, picture yourself working on a fresh web app that necessitates user authentication. The app is slated to run on Azure, and your client desires to leverage Azure Active Directory for user authentication. Although the client has some familiarity with OAuth 2.0 and OpenID Connect, he is uncertain about their implementation in the app. Thus, the client seeks your advice on incorporating Azure AD and OpenID Connect to enable secure authentication and authorization for the users. Hello, and welcome to the video, Recap Authentication in Azure AD and OpenID. In this video, you will recap the basics of Azure Active Directory, which is frequently referred to as Azure AD, and OpenID Connect, which is frequently referred to as OpenIDC, and its role in authentication and authorization. As you develop your application, securing user identities is crucial. With numerous technological options available, choosing an appropriate one for the application helps achieve security and user satisfaction. Imagine you are the owner of a transportation company. You might consider leveraging identities of your drivers already stored in Microsoft 365 to authenticate them in your scheduling app. By doing this, you wish to enhance the authentication process for your drivers to ensure their identities are secure while keeping the user experience smooth. You can utilize authentication standards and services designed explicitly for this purpose to accomplish this. By using these standards, you can authenticate your users securely without requiring them to create separate accounts and passwords for your app. Let's dive into the different standards and services that you can use for authentication. Azure AD is a useful cloud-based service offered by Microsoft that simplifies the authentication process for developers. With Azure AD, you can easily manage user identities and access to resources, all while using industry-standard protocols like OAuth 2.0 and OpenID Connect. One of the great things about Azure AD is its security features. It has tools such as identity protection and multi-factor authentication that keep your identity safe and secure. Did you know that other Microsoft services, such as Azure and Microsoft 365, use Azure AD to manage their users? Whenever Microsoft 365 has to verify the user identity, Azure AD handles all the identity and access management behind the scene. When users log in, there are two stages to the authentication process. First, the identity provider checks their identity by verifying their info in the directory. If the authentication is successful, tokens containing important information related to the authentication are issued. Next, the user passes those tokens over to the application. The application validates the security tokens of the user to ensure the authentication was successful. This extra step helps keep the user's information and data secure. Let's discuss a basic scenario where a user requires to prove their identity to access a web application through a web browser. Now, take a look at this diagram that represents this scenario. 1. When you try to access a secure resource, such as a web application, the application needs to make sure that you are who you say you are. 2. So it redirects your request to an identity provider, which is responsible for verifying your authentication credentials. 3. Once you enter your credentials, the identity provider checks if they are correct. If they are, it will generate a security token and redirect you back to the resource you originally requested. 4. You then send this security token back to the web application. 5. The web application then uses the security token to verify that the identity provider has indeed performed the authentication. Once the web application confirms your identity, it must then decide whether to grant you access to the requested resource. This is known as authorization. The entire process of authentication and authorization is built upon the industry standard protocols of OAuth 2.0 and OpenID Connect. These protocols help ensure that your access to the resource is both secure and reliable. Now, let us know more about OAuth 2.0. It is a protocol used for authorization and is considered an industry standard. OAuth 2.0 provides different authorization flows, making it ideal for web, desktop, and mobile applications. Its main purpose is to allow users to authorize an application to access data from another application. For instance, if you have an application that stores contact information and you want to allow users with LinkedIn accounts to import their LinkedIn contact information into your application. With OAuth, you can enable this kind of communication between your server and LinkedIn server. Users can grant your application access to their contact information without having to share their LinkedIn passwords. It's important to note that OAuth 2.0 is mainly used for authorization and not for authentication. As more applications started sharing data and account information, there was a need for a standard framework for single sign-on. This is where OpenID Connect comes in. Now let us move on to OpenID Connect, which is a useful authentication layer built on top of OAuth 2.0. It has some identity verification methods missing from OAuth 2.0, making it a great choice for applications requiring user authentication. One of the key benefits of OpenID Connect is that it provides both an access token and an ID token. The ID token is a JSON web token, frequently abbreviated as JWT, containing information about the authenticated user. This is helpful for applications that need to know who the user is. The identity provider signs the ID token, which makes it easy for applications to verify the authentication using the provider's public key. This is done without any encryption of the token's contents. Instead, the token is signed with the identity provider's private key, and the application can check the signature with the corresponding public key to ensure that the token hasn't been tampered with. All in all, OpenID Connect and JSON web tokens are powerful tools for authentication and secure data exchange between applications. Let us understand how OpenID Connect authentication works with the help of a diagram. So, we have three entities involved in the authentication process: the client application, the application server, and the identity provider. A client can be a mobile app, desktop app, or in this case, a web browser. The application server is usually a web browser that hosts web pages or web API, and the identity provider in the middle is Azure AD. When a user tries to access a web application, the web server needs to authenticate the user. So, it redirects the browser to Azure AD and provides its client ID, which has been previously registered in Azure AD. The user then authenticates against Azure AD, and if successful, the provider redirects the browser back to the URI on the web server. To implement OpenID Connect, you need to contain a client ID for your application by creating an application registration in Azure AD. Once you have the client ID, you'll need to copy it into your application's configuration files. In the application registration process, you also need to include the URI of your web application so that Azure AD can redirect the client back to the correct location after authentication. Let's recap. Now you have a better understanding of what Azure AD is and how it simplifies the authentication process for developers. By using industry-standard protocols like OAuth 2.0 and OpenID Connect, developers can easily authorize their applications to access data from other applications, while also providing a secure and reliable way to authenticate users and verify their identity. With this knowledge, you'll be on your way to using Azure AD to streamline your authentication process and enhance your application's security. The Microsoft Identity Platform is an evolution of the Azure Active Directory, frequently referred to as Azure AD, developer platform. It allows developers to build applications that sign in users and access resources in external Microsoft applications, other software as a service, also known as SaaS, applications, and internal resources. The Microsoft Identity Platform implements the OAuth 2.0 authorization protocol. This protocol is a method in which a third-party application can access web-hosted resources on behalf of a user. Developers can leverage one of two types of permissions depending on the application. Hello, and welcome to the video Permissions and Consent Framework. In this video, you'll learn the different types of permissions and consent framework models for obtaining permissions from users to use them in applications. First, let's discuss delegated permissions and application permissions. Delegated permissions are used by applications that have a signed-in user present. These permissions are provided to the application by the user so the application can perform actions on their behalf. This doesn't give permissions to the application. Instead, the user is simply allowing the application to act on their behalf using their permissions. Application permissions are used by applications that run without a signed-in user present. Effective permissions are the intersection of the delegated permissions, have a signed-in user present, and the application permissions without a signed-in user present. Effective permissions are the permissions that your application will have when making requests to the target resource. Remember that the application can never have more privileges than the signed-in user. Within organizations, the privileges of the signed-in user may be determined by policy or by membership in one or more administrator roles. Let's look at an example of how effective permissions work. For this example, we will assume your application has been granted the user.readWrite.all delegated permission. This permission enables your application to be used to read and update the profile of every user in an organization. If the signed-in user is a global administrator, your application can update the profile of every user in the organization. However, if the signed-in user is not an administrator, your application can update only the profile of the signed-in user. It cannot update the profiles of other users in the organization. Now we will turn our focus to Azure AD Application Consent User Experience. Consent is the process of a user granting authorization to an application to access protected resources on their behalf. An administrator or user can be asked for consent to allow access to their organization or individual data. In an OpenID Connect or OAuth 2.0 authorization request, an application can request the permissions it needs. If the user hasn't previously granted the permission to the application or an administrator hasn't consented on behalf of all users in the organization, when a user signs into an application, they're shown a consent prompt. If the user selects the Accept button, the consent settings are saved, and the user won't be prompted again. What if an organization purchases a license for subscription for an application and wants to proactively set up the application for use by all members? As part of this process, an administrator can grant consent for the application to act on behalf of any user in the tenant. If the administrator grants consent for the entire tenant, the organization's users won't see a consent prompt for the application.
Let's consider some developer best practices. Only ask for the permissions required for implemented application functionality. In addition, when requesting permissions for application functionality, you should request the least privileged access. For example, if an application analyzes a user's email but takes no action on the mailbox, you shouldn't request the more permissive mail.readWrite when mail.read will work. Applications should gracefully handle scenarios where the user doesn't grant consent to the application when permissions are requested. In the case where an application doesn't receive the required permissions, it should explain the situation to the user with options on how to remedy the issue. In this video, you learned the different types of permissions supported in Azure AD applications. You also learned about the different consent framework models and how they're used to obtain permissions from users for use in custom applications. You learned that delegated permissions are used by applications that have a signed-in user present. Application permissions are used by apps that run without a signed-in user present. Effective permissions are the intersection of the delegated permissions, have a signed-in user present, and the application permissions, without a signed-in user present. Remember that the application can never have more privileges than the signed-in user. If the user hasn't previously granted permission to the application or an administrator hasn't consented on behalf of all users in the organization, when a user signs into an application, users are shown a consent prompt. Best practices for developers include request only permissions for application functionality, request the least privileged access, and design applications to gracefully handle scenarios in which the user does not grant consent to the application when permissions are requested.
Any application that outsources authentication to Azure Active Directory, also known as Azure AD, needs to be registered in a directory. This step involves giving Azure AD information about your application. Hello, and welcome to the video, Explore Azure AD Application Scenarios. In this video, we will discuss the Azure AD functions of applications, application objects, and service principals, and the primary application scenarios supported by Azure AD. There are two representations of applications in Azure AD. Application objects. Although there are exceptions, application objects can be considered the definition of an application. Service principals can be considered an instance of an application. Service principals generally reference an application object, and one application object can be referenced by multiple service principals across directories. The application object is the global representation of your application for use across all tenants. The service principal is the local representation for use in a specific tenant. Azure AD represents applications following a specific model that is designed to fulfill two main functions. The first function to fulfill is to identify the application according to the authentication protocols it supports. This involves enumerating all the identifiers, URLs, secrets, and related information that Azure AD needs at authentication time. Azure AD does the following: holds all the data needed to support authentication at runtime, holds all the data for deciding which resources an application might need to access, whether it should fulfill a particular request, and under what circumstances it should fulfill the request. Supplies the infrastructure for implementing application provisioning both within the application developer's tenant and to any other Azure AD tenant. The second function to fulfill is to handle user consent during token request time and facilitate the dynamic provisioning of applications across tenants. Azure AD does the following: enables users and administrators to dynamically grant or deny consent for the application to access resources on their behalf. Enables administrators to ultimately decide what applications are allowed to do, which users can use specific applications, and how directory resources are accessed. Let's go into more detail about application objects and service principals and see how they work together. In Azure AD, an application object describes an application as an abstract entity. Developers work with applications. At deployment time, Azure AD uses a specific application object as a blueprint to create a service principal, which represents a concrete instance of an application within a directory or tenant. It's the service principal that defines what the application can do in a specific target directory, who can use it, what resources it has access to, and so on. Azure AD creates a service principal from an application object through consent. This diagram depicts a simplified Azure AD provisioning flow driven by consent. In this provisioning flow, 1. The user from B tries to sign in with the application. 2. Azure AD gets and authenticates the user credentials. 3. Azure AD prompts the user to consent for the application to gain access to tenant B. 4. Azure AD uses the application object in A as a blueprint for creating a service principal in B. 5. The user receives the requested token. You can repeat this process as many times as you want for other tenants, C, D, and so on. Directory A keeps the blueprint for the application object. Users and administrators of all the other tenants where the application is given consent to retain control over the application actions are permitted through the corresponding service principal object in each tenant. Scenarios can be developed using various languages and platforms. In addition, if your application needs a specific piece or segment of an end-to-end scenario, in most cases, that functionality can be added independently. For example, if you have a native application that calls a web API, you can easily add a web application that also calls the web API. This diagram illustrates the scenarios and application types and how different components can be added. When an application is given permission to access resources in a tenant, upon registration or consent, A service principal object is created. The Microsoft Graph Service Principal entity defines the schema for a service principal object's properties. These are the 5 primary application scenarios supported by Azure AD. The first is web browser to web application. A user needs to sign in to a web application that is secured by Azure AD. The second is single-page application, SPA. A user needs to sign in to a single-page application that is secured by Azure AD. The third is native application to web API. A native application that runs on a phone, tablet, or PC needs to authenticate a user to get resources from a web API that is secured by Azure AD. The fourth is web application to web API. A web application needs to get resources from a web API secured by Azure AD. And the fifth is daemon or server application to web API. A daemon application or a server application with no web interface needs to get resources from a web API secured by Azure AD. Let's recap what you've learned in this video. The 2 representations of applications in Azure AD are application objects and service principals. The application object is the global representation of your application for use across all tenants. The service principal is the local representation for use in a specific tenant. Azure AD represents applications following a specific model that is designed to fulfill 2 main functions. 1. Identifying the application according to the authentication protocols it supports, and 2. Handling user consent during token request time and facilitating the dynamic provisioning of applications across tenants. In a simplified provision flow, the user tries to sign in. Azure AD gets and authenticates credentials, prompts the user for consent, and uses the application object as a blueprint for the service principal. The user receives a token. The 5 primary application scenarios supported by Azure AD are 1. Web browser to web application. 2. Single-page application. 3. Native application to web API. 4. Web application to web API. And 5. Daemon or server application to web API. Imagine you are a software developer working for a company that wants to integrate its product with Microsoft's cloud services. Your task is to register an application with the Microsoft Azure App Registrations to obtain an application ID and authentication credentials. This will allow your application to access various Microsoft application programming interfaces, frequently referred to as APIs and services, such as Microsoft Graph and Azure Active Directory, which are required for the product's functionality. You open your web browser and navigate the Azure portal to get started. Hello, and welcome to the video, Register an Application Using App Registrations. In this video, you will learn how to register an application with Azure Active Directory and get started on building your next great app. Microsoft Identity Platform in Azure Active Directory performs identity and access management, frequently referred to as IAM, only for registered applications. Registering a client application, such as a web or mobile app, or a web API that backs a client app, establishes a trust relationship between the application and the identity provider. The trust is unidirectional. Your app trusts the Microsoft Identity Platform and not vice versa. Let us look at the steps to create app registration. Sign in to the Microsoft Azure portal. To switch to the tenant where the application is registered for multiple tenants, choose the Directories subscription filter in the top menu. Search for and select Azure Active Directory. Under Manage, select App Registration and navigate to New Registration. Enter a display name for your application. The display name is visible to users when they utilize the app, such as when logging in. The display name can be changed anytime, and multiple app registrations can share the same name. Now, you need to specify the users of the application, also known as the sign-in audience. The following are the support account types from which you can choose. Accounts in this organizational directory only. Accounts in any organizational directory. accounts in any organizational directory, and personal Microsoft accounts. Personal Microsoft accounts only. Select Register to complete the initial app registration. The Azure portal displays the app registration's overview pane when registration is completed. The application or client ID is displayed. Your application is uniquely identified in the Microsoft Identity Platform by this value. The next step in registering an app involves adding a redirect URI. Redirect URI is the location where the Microsoft Identity Platform redirects a user's client and sends security tokens after authentication. By configuring their platform settings, it is possible to add and modify the redirect URIs for the registered applications. Settings for each application type, including redirect URIs, are configured in Platform Configurations in the Azure portal. To configure application settings based on platform or device, in the Azure portal, in App Registrations, select your application. Under the Manage blade, select Authentication. Under Platform Configurations, select Add a Platform. Under Configure Platforms, select the tile for your application type or platform to configure its settings. Select Configure to complete the platform configuration. You can manually specify a redirect URI or select from redirect URIs generated for you while you configure other settings. To redirect URI restrictions, add credentials. Credentials are used by confidential client applications that access a web API. Credentials help in application authentication without user interaction at runtime. You can add both certificates and client secrets or a string of credentials to your confidential client app registration. A certificate known as a public key is the recommended credential type against client secrets. Let us know how to add a certificate while adding credentials. In the Azure portal, in App Registrations, select your application. Select Certificates and Secrets. Navigate to Certificates. Then navigate to Upload Certificate. Select the file you want to upload. It must be one of the following file types: .cer, .pem, .crt. Select Add. A client secret, also known as an application password, is a string value used by an app in place of a certificate. Client secrets are less secure than certificate credentials. You should use certificate credentials for any of your applications that are running in production. In Azure portal, in App Registrations, select your application. Select Certificates and Secrets, navigate to Client Secrets, then navigate to New Client Secret. Add a description of your client secret. Select an expiration for the secret or specify a custom lifetime. The lifetime of a client secret is restricted to 24 months or about 2 years or fewer. Microsoft recommends that you set an expiration value of less than 12 months. Select Add. Federated identity credentials are a type of credential that allows workloads such as GitHub Actions, workloads running on Kubernetes, or workloads running in computer platforms outside of Azure access Azure AD protected resources without needing to manage secrets using Workload Identity Federation. To add a federated credential, follow these steps. In the Azure portal, in App Registrations, select your application. Select Certificates and Secrets. Navigate to Federated Credentials, then navigate to Add a Credential. In the Federated Credential Scenario drop-down box, select one of the supported scenarios and follow the corresponding guidance to complete the configuration. Customer Manage Key Certificate. GitHub Actions deploying Azure resources. Kubernetes accessing Azure resources. Other issue. In this video, you learned about registering an application with App Registration. To register an application, you need to provide information such as the application name, redirect URI, and client ID. Once your application is registered, you can use the client ID and other credentials provided by the IAM to authenticate and authorize access to external resources.
Whether you are a developer seeking to construct tailored solutions, a data analyst aiming to reveal insights, or a business user hoping to simplify your workflows, Microsoft Graph offers varied solutions. With its user-friendly interface, powerful data access capabilities, and robust developer tools, Microsoft Graph represents an all-encompassing platform for building intelligent connected applications. Hello, and welcome to the video, What is Microsoft Graph? In this video, you'll learn about Microsoft Graph, the benefits it offers, and its role in retrieving organizational data. If you're looking to connect custom applications with data stored across Microsoft 365 services and improve your organization's productivity, Microsoft Graph Application Programming Interface, frequently referred to as API, provides a solution. Imagine your company is building a custom web application that helps salespeople work with customers. The sales application must provide adequate customer data to the sales team so that they can make informed decisions and close more sales. Moreover, it should also support assigning a customer to a salesperson and provide a detailed history of interactions between them. If a salesperson is setting up a meeting with a customer, they should be able to access files and previous meetings and notes. They should also be able to access emails and chats between a salesperson and a customer. They should also be aware of the point of contact in the organization that the customer can contact for support. Integrating organizational sales information in the app offers much needed support to the sales team as they prepare for and lead customer calls. Microsoft Graph is a one-stop solution for all these requirements. It provides a single endpoint that the app can use to access the required data. It also simplifies the overall development process. We all know that organizations store vast amounts of data and intelligence across Microsoft Cloud services. But have we ever wondered how accessible this data is to users? If you're looking to connect to data spread across different Microsoft 365 services, Microsoft Graph can help you out. It offers a secure and unified API that can get you access to this data. By doing so, you'll be able to make timely decisions that can give your organization a competitive edge. The best part is that developers can get started with Microsoft Graph without needing to learn about each of the individual Microsoft 365 services. Do you know that you can access various types of data and intelligence through the Microsoft Graph REST APIs and client libraries? Now let us look at some of the data that you can access. Users and groups, Teams data, tasks, files, mail, meetings and calendars, organizational charts. Also, it is important to point out that Microsoft Graph is specifically designed for accessing Microsoft 365 data. It is not related to other graph technologies such as graph databases or GraphQL. To give you a better idea of how useful Microsoft Graph can be, let's revisit the customer application scenario. Imagine you want your salespeople to work more effectively with customers, so you need an application that can do a few things. For instance, it should be able to show a history of all interactions between salespeople and customers. Let salespeople see messages they send to customers, whether through Microsoft Teams chat or email. Provide access to information about previous meetings and notes. Help identify the key people within an organization who can assist with the customer inquiries. Allow you to review any files related to a customer. Imagine if your development team didn't have access to Microsoft Graph. They would have to learn the Outlook Mail API for mail, calendar, and meetings. To get access to files, they need to learn the OneDrive and SharePoint APIs. And to find information about people in the organizational chart, and the individual skills, they need to use Active Directory queries. Those are a few APIs to keep track of. And things get even more complicated when you consider how much work goes into managing and maintaining the application over time. With Microsoft Graph, your development team can use a single endpoint and unified API to get all the customer interaction data that the application needs. Developers can access this information using Microsoft Graph's REST APIs, which are available in a wide variety of languages. Plus, there are client libraries available to make the process even easier. As your salesperson application expands, it may need to include data from other services besides the basics. These services could be anything from Microsoft 365 services, which include Delve, Excel, Microsoft Bookings, Microsoft Teams, OneDrive, OneNote, Outlook or Exchange, Planner, SharePoint, Workplace Analytics. Enterprise Mobility, plus security services, which include Advanced Threat Analytics, Advanced Threat Protection, Azure Active Directory, Identity Manager, Intune. Windows 10 services, which include activities, devices, notifications, and Dynamics 365 Business Central. But wait, what about security? Don't worry, Microsoft Graph has got you covered. It comes with built-in security features that allows you to control who has access to which services. Let's summarize. In this video, you learned about Microsoft Graph and its benefits for different users. You also learned how Microsoft Graph simplifies the development process by offering a single endpoint to connect custom apps to data stored in Microsoft 365 services. Also note that the Microsoft Graph can access various types of data, including customer interactions such as email, chat, and files. It also highlights built-in security features to control access to different services.
Suppose a company uses Microsoft Graph to develop a custom application that allows employees to access and manage their work-related data, such as emails, calendars, and documents. The company's IT team needs to configure the appropriate permissions for the application to ensure that it can only access the data that the employees have authorized and complies with its security and privacy policies. As a developer, you must decide which permissions are required to request for Microsoft Graph. Hello, and welcome to the video on Configure Microsoft Graph Permissions. In this video, you will learn about Microsoft Graph permissions and their types in detail, Microsoft Graph API and Security API, and unified and standardized alert tracking. Let's recall. You have studied that Microsoft Graph is the gateway to data and intelligence in Microsoft 365. It exposes granular permissions that control resource access, like users, groups, and emails. When users sign into the app, an administrator can approve the permissions to access resources and APIs. But when you install an app, an administrator can pre-approve the permissions if the app doesn't take a signed-in user. Once you install an app, how will you add permission? To add permissions, log into the Azure portal and select Azure Active Directory on the Azure portal. Select App Registrations. Next, select Owned Applications from the list. Then select API Permissions from the left pane. A page will open. Select Add a Permission and select Microsoft Graph. There are two types of Microsoft Graph permissions. One is delegated permissions, and the other is application permissions. To add delegated permissions, click Delegated Permissions. In this permission, the apps can use these permissions when you have a signed-in user. Here, either the user or an administrator can approve the permissions that the app has requested. The app can act as a signed-in user while calling Microsoft Graph. Now, to add application permissions, click Application Permissions. In this permission, apps can use these permissions when you don't have signed-in users. For example, apps that run as background services. Only an administrator has the right to approve the application permissions. And the third is the effective permission. When you request a Microsoft Graph, you will need these permissions. The effective permissions are visible within the Configured Permissions page. Now, let's look at the difference between delegated and application permissions in terms of effective permissions. For delegated permissions, the app's effective permissions will be the intersection of the delegated permissions that the app is granted through approvals and the privileges of the recently signed-in user. Your app never has more rights than the signed-in user. Within the organizations, the policy or membership in the administrator role can determine the privileges of the signed-in user. For example, your app has a delegated permission, user.readwrite.all. With this permission, you can read and update every user's profile in the organization. But if the signed-in user has a global administrator role, the app can update every user's profile in the organization. You can view user.readwrite.all permission in both delegated and application permission within its dropdown. For application permissions, your app's effective permissions will have the right to use all the privileges. For example, an app with the user.readwrite.all application permission can update the profile for every user in the organization. How does Microsoft Graph API work? The Microsoft Graph Security API helps to simplify security options and enhance threat protection, detection, and response capabilities. It is an intermediary service that provides a single programmatic interface to connect multiple Microsoft Graph security providers. Inside the Microsoft Graph Security API ecosystem, it also addresses queries to every service provider. Let's look at the constant workflow for Microsoft Graph Security API provided by the security provider for non-Microsoft providers. First, to view the consent form from the provider, the application user must sign in to the application. The provider owns this consent form experience and applies to non-Microsoft providers only to get explicit consent from their customers to send requests to Microsoft Graph Security API. Second, the provider side stores the client's consent. Third, the provider consent service calls the Microsoft Graph Security API to inform consent approval for the respective customer. Fourth, the application sends a request to the Microsoft Graph Security API. Fifth, the Microsoft Graph Security API checks for the consent information for the customer mapped with various providers. Sixth, the Microsoft Graph Security API calls all those providers where a customer has provided explicit consent through the provider consent experience. Seventh, you will get the response for that client from all the consent providers. Eighth, the set of responses gets returned to the application. Ninth, if the customer has not consented to any provider, no results from those providers are included in the response. Depending on your requirements, you can choose any approach to connect easily with Microsoft Graph Security. The written code will help you find code samples in Java and Node.js. You can connect using scripts to find PowerShell samples. Also, drag and drop into workflows and playbooks to use Microsoft Graph Security connectors for Azure Logic Apps, Microsoft Flow, and Power Apps. You can get data into reports and dashboards through the Microsoft Graph Security connector for Power BI. And to find Jupyter Notebook samples, connect to Jupyter Notebooks. How does unify and standardize alert tracking work? With the help of Microsoft Graph Security API connectors, you can stream alerts to security information and event management solutions, also called SIEM solutions, such as Splunk. Now, let us discuss how to correlate security alerts to improve threat protection and response. You can associate signals from other security solutions with a standard alert schema. It will enable a faster reaction to threats and asset protection by allowing security analysts to pivot and enrich alerts with asset and user information, enabling you to receive actionable alert details. Next is how to update alert tags, status, and assignments. You can tag alerts with additional context or threat intelligence to inform response and remediation. To do so, you must enable that comments and feedback on alert signs get captured for every workflow. Then, we will discuss the unlock security context to drive an investigation. You can deep dive into security-relevant inventory, such as users, hosts, and apps. Once you check the inventory, add organizational context from other Microsoft Graph providers, such as Azure AD, Microsoft Intune, and Microsoft 365, to bring business and security contexts together and improve threat response. Now, you have come to the end of this video. Let's summarize. In this video, you have learned about Microsoft Graph Permission and Security API, types of Microsoft Graph permissions, difference between delegate and application permissions in terms of effective permission, consent workflow for Microsoft Graph Security API, approach to connecting with Microsoft Security, unify and standardize alerts to improve threat protection and responsibility, how to update alert tags, status, and assignments, and how to unlock security context to drive an investigation. John is a software developer in a large organization. He knows managing confidential data, credentials, certificates, and communication between services with the technology enhancements is a big challenge. He also knows he can secure all the confidential data in Azure Key Vault, but several services need access, wherein a managed identity as an option came to his mind. Hello, and welcome to the video on Overview of Managed Identities. In this video, you will learn about managed identities in detail in terms of their terminology, types, and characteristics. You will also learn about enabling managed identities and the authentication flow for the managed identities. Managed identities provide an automatically managed identity in Azure Active Directory, also called Azure AD, for applications to use when connecting to resources that support Azure AD authentication. Applications can use managed identities to obtain Azure AD tokens without managing any credentials. There are a few common terminologies for managed identity. The first term is Client ID. It is a unique ID created by Azure AD. During the initial provisioning, you can connect to service and application principals. The second term is Principal ID. it connects to the object ID of the Managed Identity Service Principal object. You can use it to enable role-based access, also called RBAC, to an Azure resource. And the term Azure Instance Metadata Service, also called IMDS, is a REST endpoint accessible to every infrastructure as a service, also called IaaS, and the virtual machines, also called VMs, created via the Azure Resource Manager. The endpoint is available at a well-known non-routable IP address 169.254.169.254 that is accessed within the VM. Let's now learn about the two types of managed identities. The first type is a system-assigned managed identity enabled directly on an Azure resource. Next, Azure creates it for the user in the Azure AD tenant, and the user gets the credentials. The system-assigned identity to the Azure resource directly affects the identity's lifecycle. If you delete the resource, Azure automatically removes the credentials and the identity in Azure AD. The second is the user-assigned managed identity. An active subscription creates a trusted identity via a creative process and stores it in the Azure AD tenant. Once created, assigning an identity to the Azure resource is possible. Let's look at the characteristics and differences of system-assigned and user-assigned managed identities. You can create the system-assigned managed identity as a part of an Azure resource. In contrast, you can design a user-assigned managed identity as a standalone Azure resource. You can share the lifecycle with the Azure resource for the system-assigned managed identity. In contrast, you can destroy the independent lifespan for the user-assigned managed identity. Additionally, you can connect the system-assigned managed identity to only one Azure resource, whereas in a user-assigned managed identity, you can share the user-assigned managed identity with multiple Azure resources. Next, look at the detailed flow of how the two managed identities work with an Azure VM. Azure Resource Manager receives a request to enable the system-assigned managed identity on a VM. Then, they create a service principal in Azure AD for VM's identity. Next, they configure the identity on the VM by updating the Azure IMDS identity endpoint with the service principal client ID and certificate. Once the VM receives a managed identity, they use the service principal information to grant access to Azure resources. Next, they can request a token for the running VM code from the Azure IMDS endpoint accessible within VM. A call is made to Azure AD to request an access token as specified by using the client ID and certificate configuration. Azure AD returns a JSON Web Token, also called JWT, access token. Your code sends the access token on a call to a service that supports Azure AD Authentication. Next, let's learn about how to enable managed identities. As you know that securing code and its credentials are common challenges while developing cloud applications. You can store sensitive and login information via Azure Key Vault safely. You must authenticate your code with Key Vault to retrieve the sensitive information. Now let's talk about credential rotation. The resource provider that hosts the Azure resource collects the credential rotation. The default credential rotation occurs every 46 days. You can request a new credential manually to avoid waiting time. Let's look at the diagram for managed service identities that work with Azure VMs. First, you enable managed identity for Azure VM. Second, create a new managed identity service principal in Azure AD. Third, update IMDS with the new managed identity. Fourth, create the managed identity access to Azure resources or services via Azure RBAC. Fifth, request a token from the local endpoint. Sixth, request a token from Azure AD. And seventh, call Azure Service with Azure AD token. I hope now you have a good understanding of managed identities. Let's summarize. In this video, you have learned about the managed identity and its essential terminologies, types of managed identities and their differences, how to enable managed identity, the flow of the two managed identities, and what is credential rotation. In today's digital landscape, data security is of paramount importance when it comes to online communication and transactions. Web application certificates, also called web app certificates, are essential for building trust and safeguarding critical data transfers between users and web applications. It is crucial to comprehend how web app certificates function and how to manage them successfully, whether you are a developer, system administrator, or security specialist. Web browsers may display alerts if your certificate is invalid, deterring consumers from using your application because of possible security risks. Hello, and welcome to the video, Working with Web App Certificates. In this video, you will learn about the different types of web app service certificates, the use of these certificates, and the requirements of private certificates. You know that encrypting the data sent between a web application and its users, web app certificates, secure socket layer, also called SSL, or transport layer security, also called TLS certificates, enables secure communication over the internet. These certificates provide an authentication mechanism that verifies the identity of the website or service, ensuring that users connect to the intended and authentic organization. In Azure App Service, you can secure a custom domain name system called DNS and apply digital security certificates to your application code. As a result, you will receive a web hosting service that is highly scalable and self-patching. By encrypting data exchanged by your browser, websites, and website servers, the commonly used certificate TLS or SSL helps to protect internet connections. Let's now talk about options to create certificates for web app services. First is create a free web app service certificate. You can use this certificate to secure your custom domain in web app service. It is a private certificate, easy to use, and free of cost. The free App Service Managed certification is a complete solution for protecting your custom DNS name in web app service. Also, your app service plan must be in the basic, standard, premium, or isolated tier to generate unique TLS or SSL bindings or allow client certificates. The free app service certificates gets automatically renewed every 6 months with 45 days notice. The next web app certificate is to purchase a web app service certificate. Azure manages this private certificate and has automated certificate management. It is easy to renew and has an easy certificate export option. Azure manages specific tasks when you purchase a web app service certificate from it, such as it handles the purchase process from GoDaddy, performs certificates domain verification, maintains the certification in Azure Key Vault, manages certificate renewal, and synchronizes the certificate automatically with the imported copies in App Service. Let's look at Import a certificate from Azure Key Vault. This certificate is valid if you use Azure Key Vault to manage your PKCS12 certificates. You can import PKCS12 certificates if you meet the requirements of Azure Key Vault. Next is upload a private certificate. Such a feature allows one to upload a certificate from a third-party provider. And last is upload a public certificate. You can upload a public certificate into your code if your code requires remote access, but you cannot use it to secure custom domains. You must have public certificates in the .cer file format. It's vital to know that after you upload a certificate to your app, you should keep it in a deployment unit connected to the Web App Service Plan's resource group, region, and web space. As a result, other apps in the same resource group and region combination can access the certificate. What are the private certificate requirements? The Web App Service and the free Web App Service Managed certificates are compatible with App Service. If you choose to import or upload a private certificate to Web App Service, it must adhere to specific guidelines, such as exported as a password-protected PFX file format, encrypted triple data export service, also called triple DES. Has a private key that is at least 2048 bits long. It consists of the root certificate, all intermediate certificates, and other certificates in the certificate chain. But if you want to secure a custom domain in TLS binding, it must meet specific additional requirements, such as it should contain an extended key usage, also called EKU for server authentication, and a trusted certificate authority should sign it. Now you have come to the end of this video. Let's summarize. In this video, you have learned about what are web app certificates, different types of web app certificates and their uses, and the requirements of a private certificate for web app services. Congratulations on completing this module. This module focused on Azure Active Directory, also called Azure AD, app registrations, Microsoft Graph permissions, managed identities, and web app certificates. Let's recap what you've learned. First, you had an overview of Azure AD and OpenID Connect authentication. It talked about what Azure AD is and how it simplifies the authentication process for developers. By using industry-standard protocols like OAuth 2.0 and OpenID Connect, developers can quickly authorize their applications to access data from other applications. It also provides a secure and reliable way to authenticate users and verify their identity. Then, you move to the permissions and consent framework. You learned about the 3 types of Microsoft permissions for developers. When a user is signed into the application uses delegated permission. When no user is signed into the application uses application permission. Effective permissions are an intersection of delegated and application permissions. That is, an intersection between what the app is allowed to do and what the user is allowed to do. On the other hand, consent is the process of a user granting authorization to an application to access protected resources on their behalf. In an OpenID Connect or OAuth 2.0 authorization request, an application can request the permissions it needs. If users get advanced permission to access their application, the consent message will prompt on their screen. You then explored Azure application scenarios for different applications, where you learned about the 2 representations of applications in Azure AD, the application object and the service principal. The application object is the global representation of your application for use across all tenants. The service principal is the local representation for use in a specific tenant. Azure AD supports 5 primary application scenarios: web browser to web application, single-page application, native application to web API, web application to web API, and daemon or server application to web API. Then, you learned to register an application using app registrations, where you logged in to the Azure portal and went to the Azure Active Directory. Then you selected app registrations within the Manage blade and selected New Registration. You filled in the required details and selected Register. In this, you also learned how to register an app and redirect Uniform Resource Identifier, also called Redirect URI. Then you learned to create an Azure AD tenant and configure app registration, where you learned the steps that enable users to authenticate their apps using their authentication for Microsoft 365. To do so, you should first create an Azure AD tenant using the Azure portal, register the application in Azure AD, and then configure the app registration. Then, you had an opportunity to reinforce the theoretical aspects of app registration via the engaging, hands-on exercise. Next, you moved to Microsoft Graph. Microsoft Graph simplifies the development process by offering a single endpoint to connect custom apps with data stored in Microsoft 365 services. Microsoft Graph helps to integrate Microsoft 365 data into applications using identity and access management, productivity and collaboration, and people and workspace intelligence. The Microsoft Graph services have 2 parameters. A user's data is the core of Microsoft 365 cloud services, while group data is the best environment for a user's collaboration and teamwork in Microsoft 365. Microsoft Graph Explorer is a free, open-source tool where you can make Microsoft Graph REST API requests without installation or setup. Then you learned the theoretical aspect of configuring Microsoft Graph permissions. It exposes granular permissions that control resource access, like users, groups, and emails. When users sign in to the application, an administrator can approve the permissions to access resources and APIs. Then you had an opportunity to reinforce your theoretical knowledge with hands-on exercises using a registered application and add permissions. Then you explored the concept of managed identities. The system-assigned managed identities are enabled directly on an Azure resource. In contrast, the user-assigned managed identity is an active subscription created for a trusted identity via a creative process and stored in the Azure AD tenant. In configuring and enabling managed identities, you learn to set up and activate a feature that provides secure authentication and access to cloud resources without explicit credentials. Then you enforce this theoretical understanding by taking a hands-on exercise. Next, you learned about Web App Certificates. Web App Certificates Secure Socket Layer, also called SSL, or Transport Layer Security, also called TLS certificates, enable secure communication over the Internet. These certificates provide an authentication mechanism that verifies the identity of the website or service, ensuring that users connect to the intended and authentic organization. Lastly, you practice configuring and deploying web app certificates through hands-on exercises. What an incredible accomplishment in such a short span of time! Well done! You're now ready to move to the next step, the graded assessment for this module. Good luck with the module quiz.
You have explored various fascinating topics in the Secure Your Applications course. How much information are you able to retain? A course summary allows you to review and internalize key concepts and improve retention. In the first week of this course, you learned the concept of configuring Azure Key Vault access and certificates, where you have come across a definition of Azure Key Vault access and the related certificates to get access. You learned that the AZ-500 exam tests your knowledge and skills in managing Azure Key Vault access keys and secrets, securing Microsoft Identity Platform, and application security in Azure Active Directory, also called Azure AD. You have started this course with a core concept of Azure Key Vault, which protects your Azure keys to secure your data and identity in the cloud. Then you learned about the two types of Azure keys. The hardware-protected keys support the hardware security modules, also called HSMs, which offer a hardened, tamper-resistant environment for cryptographic processing and key generation, while software-protected keys rely on software-based enhanced due diligence, also called EDD and RSA algorithms. Configuring Azure Key Vault access gives you an understanding of two interfaces, the management plane and data plane, to control Azure Key Vault access. While reviewing Azure Key Vault, you knew that you should identify the secrets and keys first, define the roles, and identify the tasks that you can perform by these roles for controlling access to application keys and secrets. The Deploy and Manage Azure Key Vault certificate provided a practical aspect with different steps to add Azure Key Vault certificates by creating a certificate sign-in request. What else for you in week 1? In key management in Azure Key Vault, you practiced creating Key Vault keys, exploring the various available key types, and the best practices for key management. Once you have created Azure Key Vault and populated it with keys and secrets, the next step is to set up a rotation strategy for the values you stored as Key Vault secrets. You can rotate secrets in several ways: as part of a manual process, programmatically by using representational state transfer API, also called REST API calls, and through an Azure automation script. Then you studied enabling Azure Key Vault secrets, which talks about Key Vault stores and manages secrets as sequence of octets, 8-bit types with a maximum size of 25 kilobytes each. The Key Vault service doesn't provide semantics for secrets. In managing access to secrets, certificates, and keys, you learned that Azure Key Vault access involves managing the Key Vault itself and accessing its data. Authentication is done through Azure AD, while you can use Azure Role-Based Access Control, also called Azure RBAC, for authorization. Access policies define permissions for reading and writing data. You can restrict network access to subnets, IP addresses, or trusted services. You also learn to create secrets using Azure Key Vault. Here you learn how to update and delete the secret versions and view the secret value. You can also restore the deleted secret versions. Let's now move to week 2. This week started with the core concept of the Microsoft Identity Platform, which includes application security and single-page applications. This week, you also learned how to register web apps that sign in users and call APIs, which helped you register a single-tenant Azure AD app and create a client secret. It also taught you how to configure authentication for web apps using Azure AD. Then there was a concept of daemon and non-interactive applications. Daemon applications, also called apps, run without user interaction. Here you learned a few examples of daemon apps and how to register an app that obtains tokens without user interaction and add permissions to the app. In week 3, you have started your journey with the recap, authentication in Azure, and OpenID Connect. In Azure AD, you can easily manage user identities and resource access while using industry-standard protocols like OAuth 2.0 and OpenID Connect. The OpenID Connect is a helpful authentication layer built on top of OAuth 2.0. It has some identity verification methods missing from OAuth 2.0, making it an excellent choice for applications requiring user authentication. You learned about delegated application and effective permissions in the permissions and consent framework. You also learned that consent is a process of a user granting authorization to an application to access protected resources on their behalf. An administrator or user can request consent to access their organization or individual data. Then you had a practice on how to register an application using app registrations and add certificates. You learned about the Azure AD tenant by creating an Azure AD tenant and configuring app registration. A tenant is an instance of Azure AD that represents an organization. An organization or app developer receives a dedicated instance of Azure AD. Organization or app developer creates a relationship with Microsoft, like signing up for Azure, Microsoft Intune, or Microsoft 365. Then you have learned about the application objects and service principles in exploring the Azure application scenario. You also learned about the 5 primary application scenarios supported by Azure AD. In Microsoft Graph, you learned about the benefits of Microsoft Graph and its role in retrieving organizational data. You also learned that Microsoft Graph services are user and group-centered. Then you learned how to grant delegated and application permissions using Microsoft Graphs. You also learned that the Microsoft Graph Security API helps to simplify security operations and enhance threat protection, detection, and response capabilities. Furthermore, you knew how unified and standard alert tracking works. Managed identities provide an automatically collected identity in Azure AD for applications to connect to resources supporting Azure AD authentication. Creation, lifecycle, and sharing across Azure resources are 3 characteristics of managed identities. While configuring and deploying managed identities, you will practice a step-by-step process to grant permissions for system-assigned and user-assigned managed identities. You should have access from your app or function to configure target access. With managed identity, an app can obtain tokens for Azure resources that Azure AD protects, such as Azure Structured Query Language Database, also called SQL Database, Azure Key Vault, and Azure Storage. These tokens represent the application accessing the resource and not any specific user of the application. What else do you have? You learn the most important concept of web app certificates, which provide an authentication mechanism that verifies the identity of the website or service, ensuring that users connect to the intended and authentic organization. Creating and purchasing web app service certificates, importing certificates from Azure Key Vault, and uploading private and public certificates are certain processes of web app certificates. While configuring and deploying web app certificates, if you create custom transport level security (TLS) or secure socket level SSL bindings, or enable client certificates for your app service app, then your app service plan must be in the basic, standard, premium, or isolated tier. Before creating a free managed certificate, ensure you have met the prerequisite for your app. Store certificates in Azure Key Vault is an Azure service that helps to safeguard cryptographic keys and secrets cloud applications and services use. Also, you learn how to create web app certificates, buy them, import and upload them, and their prerequisites. Finally, you learn how to delete an app service certificate. You can revoke a certificate, and any binding in app service that uses this certificate becomes invalid. Great job on completing your learning journey. You are now ready to move on to the course project. The project offers an exciting chance for you to put your new learning into practice, receive valuable feedback from peers, and provide feedback on their work in return. When was the last time you felt the thrill of completing a milestone? Here is an opportunity for you to immerse yourself in that feeling again. Graded assessments allow you to prove your capabilities and celebrate your progress. Hello, and welcome to the video about the graded assessment. In this video, you will learn important details related to the graded assessment. You have learned all the concepts covered in this course. Secure your applications. You might have completed the hands-on exercises to strengthen your learning. Now, it is time for the final graded assessment. This assessment will test your understanding of using various security measures and services to enhance the security of applications. The graded assessment evaluates your knowledge and understanding of the course content. It provides valuable feedback on your exam-taking skills, such as time management and test anxiety, that you can apply to your exam preparation strategy for the AZ-500 certification exam. The graded assessment also provides valuable insight into areas you need to improve. There may be several aspects of the assessment that you're curious about, including the number of questions, how the scoring will be done, and the assessment duration. To better understand these details, let us dive deeper into the specifics. What type of questions can you expect in the final graded assessment? The graded assessment consists of multiple choice questions. You will often be presented with a scenario that you must carefully analyze to answer the question correctly. You will notice that the question formats are similar to the knowledge checks you have completed throughout the course and the module-level graded assessments. We have designed this question format to help you feel more at ease with the types of questions commonly found on the AZ-500 exam. Each question in the graded assessment carries a value of 1 point, with a total of 20 points available for you to earn. It is important to note that there is no negative marking for incorrect answers. Even if you're unsure about a particular question, it is still worth attempting to answer it to the best of your ability. Do not be afraid to make an educated guess if needed. In addition, the graded assessment allows you to navigate back and forth between questions and modify your answers before submitting your final responses. This feature allows you to review your work and make any necessary adjustments to ensure you are fully satisfied with your answers before submitting the assessment. It is important to note that you must achieve a score of at least 80% to pass the assessment. This means that out of the 20 questions, you will need to answer at least 16 correctly. It is important to take your time and read each question carefully before selecting your response. What is the assessment duration? To ensure you have ample time to carefully consider each question and provide thoughtful responses, we have designed the final graded assessment to last 1 hour, giving you approximately 3 minutes to answer each of the 20 questions. Unlike the AZ-500 exam, there is no time pressure to complete the assessment within the stipulated time, as no timer will stop you from continuing after the allotted time has passed. Nevertheless, we strongly advise you to complete the assessment within 1 hour to practice for the speed expected in the AZ-500 exam. As you prepare for the graded assessment, remember that you can still brush up on any key concepts you may want to review. Take advantage of this time to refresh your knowledge about configuring Azure Key Vault access and certificates. Also, review the content covered about the Microsoft Identity Platform. You can also review what you learned about registering an application. It will be a good idea to revisit creating an Azure Active Directory tenant and configuring registration. Reviewing the content on configuring Microsoft Graph permissions and managed identities will be useful. Also, do not miss out on refreshing your knowledge of web app certificates. You may remember that for the AZ-500 certification exam, you have the option to take the exam at a test center or from the comfort of your own home. To prepare effectively for the AZ-500 certification exam, we recommend that you recreate a similar environment for this graded exam. This includes finding a quiet space to take the exam and closing all other applications and browser pages to simulate the exam conditions. Best wishes for the final graded assessment of the course Secure Your Applications. Congratulations! You have completed the course Secure Your Applications. This is the fourth course in a series of 7 courses in the Microsoft Azure Security Engineer Associate Professional Certificate Training Program. This course is part of the preparation for the AZ-500 Microsoft Azure Security Technologies exam. The content you learned in this course aligns to the secure compute, storage, databases, and secure networking area of the AZ-500 exam. Recall that you can expect 20 to 25% of exam questions from this area. By learning the content in this course, you have prepared well to answer questions on managing Azure Key Vault, network security principles, and best practices. You learned about what Azure Key Vault is, manage Azure Key Vault keys and secrets, and application security with the Microsoft Identity Platform. You also learned web apps, sign-in users, and call APIs, and configure authentication in daemon and non-interactive apps. Then you learned about application security with Azure Active Directory or Azure AD and other Microsoft tools. You also learned about the Microsoft Graph, managed identities, and web app certificates. You have now moved one step closer in your preparation for the AZ-500 exam. Remember to refer to the Microsoft website to view the latest updates on the AZ-500 exam. Before you sign off from this course, you will watch a video on the next steps that you will take to proceed further in this training program. See you in the following video. Well done! You have made it to the final video of the course Secure Your Application. Take a moment to acknowledge and celebrate this accomplishment. Your next step is to move to the next course, Secure Your Data at Rest. This is the 5th course in this series of 7 courses that prepare you for the AZ-500 certification exam. The concept of Secure Your Data at Rest will help you define data sovereignty in IT security, deploy shared access signature, also called SAS, configure blob data retention policies in Azure, and enable Defender for Structured Query Language, also called SQL. What are other aspects covered in the next course for you? You can define data sovereignty. It provides information that has been converted and stored in binary digital form and is subject to the laws of the location. Then there will be a concept of Azure Storage Access. In this, you will learn how to authorize Azure Storage Access requests against a secured resource in a blob, file, queue, or table service. Then you will learn about the SAS. It is a string that contains a security token that can be attached to a uniform resource identifier, also called URI. You can use SAS to delegate access to store objects and specify constraints, the permissions, and the time range of access. Then you will touch on managing storage account keys and rollover. How do you do that? When you create a storage account, Azure generates 2 512-bit storage account access keys for that account. You can use these keys to authorize access to data in your storage account, shared by key authorization or SAS tokens signed to the shared key. Next, you will learn about the storage access policies. It provides control over service levels on the server side. It also establishes stored access policy groups and provides more restrictions for signatures bound by the policy. Then there is a concept of implementing storage service encryption. Azure Storage automatically encrypts your data when persisting it to the cloud. Encryption protects your data and helps you to meet your organizational security and compliance commitments. Next, you will learn about the overview of database security. Databases are the most common places to store and process data. You can protect your databases from attacks by using data encryption masking, firewalls, and auditing. Then there is how to enable a SQL database authentication. You can enable SQL database via authentication and authorization. You will also learn how to enable and monitor the database. It will cover the concepts of the audit logs returned to append blobs in an Azure Blob storage account. You can apply audit policies at the server level or database level. What is next for you? You will learn the essential concept of the Defender for Cloud. It is a security software product that protects and secures your hybrid cloud environments in Azure, Amazon Web Services AWS, Google Cloud Platform GCP, and on-premises. Then there is a concept of data masking and encryption. In this, you will learn transport layer security, also called TLS network encryption, transparent data encryption, and dynamic data masking. And the last concept will be to deploy an always encrypted implementation. Here, you will learn the initial step of always encrypted in a database that involves constantly generating encrypted keys, creating key metadata, configuring encryption properties of selected database columns, and encrypting data that may already exist in columns that need to be encrypted. Who doesn't like to try out things themselves? The Secure Your Application course provides you with practical skills through hands-on exercises. For example, the course provides step-by-step instructions on generating key tokens, testing key rollover, creating stored access policies and storage endpoints, configuring Azure AD authentication, and enabling Defender for SQL. In this video, you learn that your next step is taking the 5th course in this training program, Secure Your Data at Rest. Are you ready to take your Azure security skills to the next level? See you in the next course.